All right, Jordan. I'm working out this paper for you. I know that I did the exam today. I promise to work the paper out for you. But I'll share it on my channel so that other persons can go and look at it. So this is the June 2023. This is the June 2023 pure maths paper 2. All right, that's it. Get a copy of it today. June 2023. And this is the pure maths paper. Unit 1, paper 2. All right. So let's see what it was all about. For some persons complaining that it was rather difficult. Let's see. Just gonna just work through it and see what is it. Just got the paper. I'm kind of anxious to see what it is all about. All right. All right. Let's go. So we're gonna work the questions, and I'm not teaching. Just basically working the questions. So I'll explain a few things, but for the most part, I'm basically just working the questions. All right. Doing this for Jordan in Tobago. All right. First question here. It's your truth table. So they give those two statements, propositions, P and Q, and I want us to complete the truth table. This is a conditional statement. P implies Q. If P, then Q. Generally speaking, we want to highlight the true and the antecedent, false as a consequent. This is going to be false. That's all. That's the only one that's going to give you a false. And we're going in this way. If P, then Q. This is a false. Everything else is true. Right? And then on this one, we're going from Q is the antecedent, P is a consequent. So we're going this way now. Again, looking for the true on this side and the false on that side. So the true and the false is right here. This time. That's the only one that is false. True implies false is false. Everything else is true. All right, that's what we have so far. And then here now, we're doing the and between these two. So we're doing this and that. So doing the and between these two. All right, remember, this is the and, the conjunction, I think. Right, I've not done this in a while, so excuse me if I'm not using some of the correct terms. I've not done this in a while. Didn't teach pure maths at all for the past 2 years. But I think this is the conjunction, meaning and. I know it means and. And is true only when both of them true. So true and true is true. False and true is false. True and false is false. True and true is true. Right? That is it. It says, hence, state whether the statement Q implies P and this statement are logically equivalent. So the Q implies P is this one. This one we're talking about. Right? And then this one is the conjunction with the proof statement, which is this. And if I were to mark the values that are not the same, this value, these two values are not equal. Everything is good except those two. And because we have that, it means that they are not logically equivalent. Reason that the values in the truth table are not equal. They have to be equal right through. Right? Truth values are not equal. Let me reduce the size of the pen a little bit. It's okay. So they are not logically equivalent. And state whether or not they are logically equivalent. So I'm going to say they are not. They are not. Talking about these two statements, right? Logically equivalent. Because the truth values are the values in the truth table. They truth table values. The truth table values are not equal. That's it. Right? These cause them not to be equal. And that's it. Next one. Next one says, let x and y be negative real numbers. Negative real numbers. That means that x is less than 0 and y is also less than 0. All right. So x is a negative number and y is also a negative number. That's what they're saying. But they are also real, right? Negative real numbers. And z is any real number. So z is any real number. All right. So these two are also real, right? These two are also real. So I'm just going to write like this. These two are also real numbers. R, set R. It says use a counterexample to show that this statement, if x is greater than y, remember both of them negative. If x is greater than y, then yz is greater than y. Xz is greater than yz is false. We have to use a counterexample. Is basically just want to give x, y, and z some actual values and show that this statement is not true. All right, so 1, 2 values that will have the x value greater than the y value. So if we were to show them on a number line, right, both of them negative. Both of them negative. So this is 0, and you want the x to be greater than the y. So you want the x to be here and the y to be here. So the x could be a value like, for example, -2, and the y could be a value like, for example, -3. So those would be good examples, all right? Those would be good examples that we can use. They said that they're both negative, right? And then now they said z is any real number. But look at what does that mean now. What does that mean is that they're multiplying this inequality with a number where the sign, they don't have the sign reversing. The sign is staying greater than. And we must know that when we multiply any inequality by a negative number, the sign must be reversed. So to prove this as a counterexample, it makes sense to choose a z. Remember, z can be any value now. Choose a z value that is negative, because a negative z value will basically prove this statement, right? Not to be true, to counter that statement. So we're going to choose a z value. So we're going to choose a z value that is negative. So let's do the proof now. This is the proof we're doing now, right? Let's do it in red. So I'm just setting up what we're going to do, how we're going to prove it. You have a kind of think, when you're doing a proof by example, you have a kind of think it through a little bit first, right? What you're going to do to prove it. So when I say let x equal -2, y equal -3. And we can just make z equal a simple number like -1. Let z equal -1. Just want to make sure that it's negative. Z equals -1. Just want to make sure it's negative because it will allow us to disprove that statement. Prove that that statement is not true. Not let z equal -1. And these two, as we know, is satisfying the condition right here. So we can say that is the x is greater than y. And then now we're going to show that we multiply through by the -1, the z. We're going to multiply through by the z now, right? So we can say that let's put in the values. So the x is greater than y, which means that the -2 is greater than -3, which is true. And I'm going to multiply by the z now. And I run out of space. Let me see if I can make it a little bit smaller. Make it a little smaller. Run out of space. Let's zoom it up. Like that. Right, and then we can zoom it up, right? So what I'm going to do now with this inequality, so I have this condition that told me right here, right? I'm going to multiply it now by the z. I'm going to multiply by the z. So let's put it, I'm going to multiply this inequality by z, which is -1. I'm going to multiply by -1. So I'm going to get multiply by -1, I'm gonna get the zy, the zx, sorry. I'm gonna get the zx or the xz, same thing. I'm gonna get x times z, and I'm gonna get, let's put it this way, the xz, and I multiply by -1, the xz, I multiply by -1. What will that mean is that the xz will become -2 times -1. It becomes -2 times -1, which becomes a +2. And the yz, or the yz, and the yz becomes -3 times -1, which is +3, which is telling us, which is implying that the xz, the xz is actually less than, see, but it is 2, you know. The xz is actually less than the yz. That is, the 2 is less than 3. Therefore, by counterexample, that statement is not true. It's something like that you have to. All right, let me move these out of the way, because these are not a part of the solution. These are just helping us to choose our values. Let me move this up here and make it smaller. All right, these were just basically choosing our values. So based on this calculation, we can say, therefore, by counterexample, this statement is not true. All right, so we can, based on this calculation that we just did. I don't have a lot of space, but you know, we get the picture. So let me shift this over to the left. All of this. Shift it over here. Make it smaller a little bit. Shift it over here. And then write over conclude. Let's write conclude in a different color. And this basically disproves it. It just disproved that while ago it is not true, because it comes out negative. All right. So we can say therefore, by this counterexample, the statement that says if x is greater than y, then xz is greater than yz, and it's where the x and y are negative enough. So we can state that as well. Again, I have to make this smaller, because I run out of space. I give such a small amount of space to do this work. So when I say where the x and the z, x and the y are less than 0, and they are also real, and the z was real, and the z was real, is not true. This statement is not true, is false. See, true that it is false is false. Something like that. This will be good enough. Right? I don't remember the exact way to present it and stuff, but that is it. I know that proof by counterexample, you just want to give some values that will disprove what they want you to prove, not to be true. So this would be good enough to do it, those values. That's what proof by counterexample is. Find an example that will cause the statement that they give you to be false. And that's what we did right here. Show that the statement is false. They are saying it will be greater than, and we got it to be actually less than using the numbers that we have here, which basically satisfy these conditions that they gave us. All right, that is it. Let's move on. And this is just an example. You don't have to be this particular way. So this paper is kind of scanned side by side. So the next question is over here, which is polynomials. All right, let's go. So this one says they give us this function f of x. They say it is divisible by this. So if it divisible by this, this means that f of a half is equal to 0. I'm not teaching, I'm just, you should know that. It means that f of a half is equal to 0, and it leaves a remainder of 2 when divided by x minus 1. And this means, this statement means, this one, let me zoom it up. It means that f of 1 is equal to the remainder over here of 2. So basically, these are the two equations they're going to solve. And you're going to set up an equation with this, set up an equation with this, and then you're going to solve them simultaneously. So you have two unknowns, and so you need two equations. All right? So ready. We're doing the f of half equals 0 first. So we're going to do the f of half equals 0 first. What will that give us? F of half equals 0. So plug in a half in this and put it equals 0. So a half in that gives us 1 over 8. So we're going to get 6 over 8. A half in this gives us a quarter. So we're going to get a quarter p. A half in this is going to give us half q. And then we have the plus 2, and this is equal to 0. I don't want all that fraction all over the place. I'm going to multiply by 8 first. I'm going to multiply 2 by 8 first. I'm going to get 6 plus multiply by this by 8. I'm going to get 2p. Multiply this by 8. I'm going to get 4q. Multiply this by 8. I'm going to get 16 equals 0. Then I consolidate. I'm going to get everything can be divided by 2 here. So again, that's because I multiply 2 by 8. But it doesn't really matter. So I'm going to consolidate this. I'm going to get 2p. I'm going to get 2p. Should I multiply 2 by 4 instead? Yeah, should I multiply 2 by 4 instead, because this is actually 3 over 4. Yeah, multiply 2 by 4. Let's do the mathematics the easy way. Multiply 2 by 4 instead and save this line. So multiply 2 by 4 instead. Multiply by 4 instead, right? Because then now I have to divide by 2 again. Multiply this by 4. I'm going to get, this is same as 3 over 4, as I said, so I'm going to get 3. I'm going to get 3. Multiply this by 4, I'm going to get p. Multiply this by 4, I'm going to get 2q. Multiply this by 4, I'm going to get 8 equals 0. Then I'm consolidating these two values. So I get p plus 2q plus 11 equals 0. That's my first equation. Let's mark that equation 1. I'm going to get another equation from this now. F of 1 equals 2. Let's do that now. So I'm going to do another one. F of 1 equals 2. I'm doing f of 1 with the blue. F of 1 equals 2, which tells me then I'm going to plug 1 in the function up here. Right? Plug 1 in that function. So when I plug 1 here, I'm going to get 6. Plug 1 here, I'm going to get p. Plug 1 here, I'm going to get q. And the plus 2, and that is all equal to 2 over here. I mean that's 2. And I'm going to simplify this now. This 2 cancel out this 2. So I'm going to be left with p plus q plus this 6 plus 6 equals 0. And so that's my equation 2 right here now. Equation 2. So I'm just solving those two equations simultaneously. So I can subtract, eliminate the p, I can subtract. So I'm going to do equation 1 minus equation 2. I'm subtracting the two equations. All right, to eliminate the p. I'm going to find the q value first. So when I do equation 1, the p minus the p that gone. 2q minus q is q. Then 11 minus 6. 11 minus 6 is 5 plus 5. And then 0 minus 0 is 0. So that means that the q is equal to negative 5. That is the q. How much space you have? What about that space? All right, no problem. Q equals negative 5. I can write it under here. How about that space? So the q is equal to negative 5. All right. Now that the q is negative 5, you can find the p by substituting the negative 5, for example, in this equation right here for the q. So we can just say and p minus 5 plus 6 equals 0. That's what we substitute it in equation 2. Let me indicate that. That's what equation 2 gives us. Equation 2 is telling us that. So this works out to be 1. 1 goes over, and so the p becomes negative 1. So p equals negative 1. Because this is a positive 6. Positive 1, I mean, goes over, become a negative 1. So those are my two values of p and q. This is one answer, and this is my other answer, two negative values. All right, that's what they wanted, right? The value for p and q. All right, that's done. Nice and easy question. This question like this can come even an odd marks. 9 marks, so that's, you know, wow. 9 marks. Simultaneous equations. Wow. All right, that is that. Next question right here. It's a logs question. All right, very easy stuff. So we're gonna the division here means that that means that we're gonna, the minus here, sorry, means that we're gonna divide the logs, right? We're gonna get the log of the quotient. So this side is gonna become, I know that this is the difference of 2 squares inside here. All right, this right here is the difference of 2 squares. But in any case, the equation, the logs equation initially is gonna become log to base 3 of x squared minus 9 divided by the x plus 3. That's the law of logs, and that is equal to 3. Right? And then this up here now is the difference of 2 squares. And then it also means that this becomes a power. Using the laws of log, I'm going to write it over from logs to indices. And it is this. Log of a number to a base is equal to a power. This implies that the number is equal to the base raised to the power. So in this case, this is our n, this is our b, and this is our p. Right? Number, base, and power. Number, base, and power. Right? So it means that this number, let's write it now. Right? So it means that the x squared minus 9, which we can factorize over the x plus 3, that number is equal to the base of 3 raised to the power of 3. Which basically that is 27. But this, as I said, can be factorized. Solve it now. See? So it becomes x minus 3 times x plus 3 divided by the x plus 3 equals 3 cubed is 27. And so these cancel each other. This cancel that. If that cancel that, we're left with x minus 3 equals 27, which means that the x equals 20, x equals 30. So this means that our answer is that x equals 30. Now, whenever I'm doing a logs question and I get a value, I like to try and see that value would work in the original equation. Right? So if we plug the 30 in the original equation, remember you can only find the log of a positive number, you know. So any value that will cause it to be find the log of a negative number is not acceptable. So we plug the 30 inside here. This will come out positive, and also this will come out positive. So the 30 is a good answer. Okay, you can't find the log of 0 and you can't find the log of a negative number. Those don't exist. All right, when the base is positive. All right, let's continue. Right. This question says we are to show that this is equal to that. But first thing I want to note is that we have a 5x inside here. So it means that I want to factorize out 5x out of these terms. That's what I'm going to start. Right? Factorize out 5x. 5x out of this and out of this under the square root sign. I'm going to say the left, let's call this left hand side. I'm going to say the left hand side. Let's call it left hand side for now. Change the color to purple, to blue. Let's call it left side. I'm going to call this the left hand side and this the right hand side, right? I'm calling this left hand side. I'm calling this right hand side. I want to show the left hand side is equal to the right hand side. It's a proof. All right. So the left hand side, I'm going to factor the 5x out of this. So I need to divide the 320 by 5 first. So let's see what that is. 320 divided by 5 Give me 64. I'm gonna get 60 on the square side. I'm gonna get 64 x squared. Remember, I'm factoring 5x out of that, you know, times by the 5x. That's what that gives me. That's it. That's the perfect square. And I'm gonna factorize the 5x out of this as well. And 125 divided by 5. 125 divided by 5 is 25. So I'm gonna get the square root of 25x squared. And then I'm left with now 5x. So I know that I need a 5x based on what I see under here. So this becomes a perfect square. Square root of the 64 is 8. Square root of the x squared is x. So this here becomes 8x times the square root of 5x plus square root of this now is 5x. Root of the 25 is 5. Square root of the x squared is x. So this becomes 5x times the square root of this 5x. And then you have the 8x and the 5x adding up, because this like is now a common factor. Like you have 8x of this and 5x of this becomes 11x of that same thing. So this becomes 11x of the square root of 5x, which is equal to the right hand side. And so we have shown it, right? So that is quite easily brushed aside. All right, that was done nicely. All right, beautiful. This is Parametric. But I hear that the first part of the paper was easy. I hear that the trouble came in the second part. But let's see. All right, we're coming over this side now. So far, so good. This one now. All right, so this one says it gives us that linear function, and this I must prove that it is bijective. Right? Because I didn't mention any domain, right? We're gonna take it that x is on a set of real numbers. All right, so we're gonna take it that there's no restriction. So we're gonna take it that x is a member of real numbers, right? We're only operating on real numbers in this function. That's the first thing. There are no limitations. All right, x is any real number. That's what we're gonna say for this function. All right. So to prove that it is bijective, or to prove that it is injective and surjective, that's what bijective means. Injective is one-to-one. Surjective is onto. All right. So bijective is when it is both. So we're gonna do the two tests separately, right? So we're gonna do the one-to-one test. One-to-one test, which is injective. One-to-one test, which means injective, right? Injective. I'm using the right terms because I've done this in a while. Injective, we have injective and surjective, right? So one-to-one test. We're doing the injective one-to-one test. So that test is that you run f of a equals f of b, where a and b are real numbers. Now, if the result of this is only a equals b, it means that the function is one-to-one. That's all I have to do. If the result of this test is that a equals b, then if that is the only possible solution, it means that the function must be one-to-one. It means that f of a can only equal f of b when the a and the b is the same value. So it means that it's a one-to-one function. So the f of a on this side would be 7x plus 2. And the f of b on this side would be 7b plus 2. So clearly this is going to give you a equals b, because the 2's cancel and they divide by the 7. That should have a right here. Right? So the only solution is a equals b. A equals b is our only solution. Therefore, the f function is one-to-one in injective, one-to-one. All right. Then we're gonna do the onto test, or what we call the surjective test. All right, and that is basically a test to say that all elements in the codomain is as an image in the domain. It's the image of an element in the domain. All right. In other words, for all output values on the function, there is an input value that is mapping to it. In other words, there are no free elements in the codomain. That's what we're basically testing. So we're going to do the surjective test, the surjective. So we're going to test if it is surjective. So let's call it the surjective. All right, let's write the other term for it is onto. The onto, which is a surjective. Surjective test. Or using a calculation method. These tests can be done graphically too, you know. Right? But I'm doing the calculation type. Let me see how much space I have. A lot of space. Let me make this smaller. Let me make this smaller. So I'll fit everything up here. Select everything and just make it smaller. Right here. Shift it over. All right. So I'm doing the surjective test now. All right. Surjective. I'm underlining them. So first we did the onto test. Now we did the one-to-one test, which is injective test. Now we're going to do the onto test. Now to do the onto test, because basically we're gonna solve. You're gonna solve. Here we should write the word solving. We're gonna solve f of a equals b. If f of b and if a equal b is the only solution, then yes, it is 1-to-1. That was true. But this one now we're gonna solve. We're gonna solve f of a equals b. Where both a and b are real numbers again, because we're operating on the set of real numbers. So we can say the a and the b are both real numbers, right? So the input values are real and the output values are real. Now what it is that this is a domain value and this is a codomain value. That's what it is, you know. So you have to set up the function, transpose it, and see if there is any b value that will cause you not to have an a value. And if there's no b value that can cause you not to have an a value that is real, then it means that the function is onto, meaning there are no y values or codomain values. There's no codomain value that does not have an image, does not have an object in the domain mapping to it. All values in the codomain is an image of a value in the domain. That's what you basically want to do. So you set it up. The f of a becomes 7a plus 2 equals b. They transpose to make the a the subject. I want to give b values. So you're going to make a the subject. Some teachers teach it by finding the inverse first. But here, the a would be equal to b minus 2 divided by 7. What this means is that any value you give to b, you're gonna get a value that is real, right? So you can say for any b that is real, there exists an a value that is also real. So in other words, there's no codomain value that doesn't have an a value mapping onto it. All right? So that means that the function is surjective. There's a statement you have to write now. So for any b value that is real, there exists an a value that is also real, which therefore means that f of x is surjective. And since it is injective and surjective, it means that it is bijective. So you can write the conclusion down here. So therefore, f of x is bijective. Sorry, it is bijective. I hope I use the right word. If it is injective and surjective, it means that it is bijective. It is bijective. That's a word meaning both of them. Bijective. And that is a proof. All right, 5 marks for it. Maybe we could just use a graphical method and stuff, but I think sometimes the calculation will be kind of easier to show it. All right. But that is it. All right, finish that. All right, still on question one, Still on question one. So the question along, they usually have about 4, 5 parts. There's only 6 questions. All right, so this is part B now. So this is your classic 3 roots cubic equation, right? Sum and product of roots of cubic equation. That's what this is. And it's very similar to sum and product of roots of quadratic equation, almost the same thing, just that you have one additional root. So this gives us this equation, and it says roots are alpha, beta, and lambda, or gamma, whatever that is. Right? I know this is alpha, beta, I don't remember that. I think that is gamma. Right? Don't matter. We're gonna need the sum and product of them, guys. We're gonna need them of this equation, and they can be expressed in terms of the A, the B, and the C from the equation. Now, if you look at this equation, let's write it out. What the A is, the B is, and the C is. The A is the coefficient of the x cubed, which is 3. The B is the coefficient of the x squared right here. There's no value in it, and it's only -1 negative in it, in front of it. So it's a -1 is a coefficient. Then the C value is the coefficient of the x, which is -2. And the D that we're going to use is this 1, the constant value out here, 1. The equation already have 0, that's why we can put the A, the B, the C, and the D. Now the sum of those roots, which is alpha plus beta plus gamma or lambda, whatever that is, you can write it here. The sum of the roots, alpha plus beta plus gamma. I'm just writing a Y for my gamma. I can write this symbol, no matter, is equal to minus B over A, just like for some of the roots in add maths, minus B over A. So it becomes minus this value over this value. So basically it becomes a third. All right? Minus a -1. Let me write it. It becomes minus a -1. Minus a -1 divided by A, which is 3. So it becomes a third. All right? And then the pairwise product means that the product of the two terms, when you pair them up. All right? If there are 2 roots, you only have 1 pair. There are 2 roots, but still equals C over A. So this is alpha beta plus alpha gamma plus beta gamma. That's the product of the roots when you pair them up, right? Called the pairwise product, or the product of the roots pairwise. It is equal to C over A, just like the product of the roots when it's 2 roots. And that now would be the C value is -2, and the A value is 3. So -2 over 3. You have the product of the 3 roots now, which is alpha, beta, gamma. That now is minus D over A, minus D over A, minus D over A. And so that is -1 over 3. And so you have these 3 values. You're going to need them to calculate the equation. You're forming a new equation with these 3 roots. That's what this question is asking us. What space do we have? Let me see. We have the word page. All right, 8 marks. Wow. 8 marks. So this is just easy work, which is just work to do. All right. So let's change the color now for the new equation and show you what is that mean. All right, so see here now, new equation. We're forming a new equation now, a new cubic equation, new equation with roots. 1 over alpha, 1 over beta, 1 over lambda. That's from these. Those are the roots. That equation, sorry, is. I'm going to write the form that is going to be in. It's going to be in the form x cubed minus the sum of these 3 roots times x squared plus the product pairwise of these same 3 roots times x minus the product of the 3 roots equals 0. This is what we have to know. The equation can be written in this form. The equation can be written in this form when you have the sum and the product of the roots. Just like in add maths. This is the form for pure maths, right? With the 3 roots. So we need to find the sum of these 3 roots. We need to find the sum of these 3 roots. That value is going to go there. We need to find the pairwise product of these 3 roots. And we need to find the product of these 3 roots. And we need to get them, and these will be used to find those things. All right? So let's go step by step now. The sum of the 3 roots, I'm going to call it S. S for the sum. So the sum of the 3 roots, working them out on the sum. So the S first, let's do it here. The S is a different color. Let's use a different, let's use the red. As if we're working out the values that we need for here, here, and there. Let's use the red. So the sum of the rows S is gonna be 1 over alpha plus 1 over beta plus 1 over gamma. All right. And what it is, you want to make the three denominators the same. So it means that this one have a multiply numerator and denominator by beta gamma. So the numerator is going to become beta gamma over alpha beta gamma plus multiply this one now by alpha and gamma. Numerator and denominator, so it becomes alpha gamma over alpha beta gamma plus multiply this one now by alpha beta, numerator and denominator by alpha beta. So you're going to get alpha beta over alpha beta gamma. Gamma. All right, so gamma. And this is gamma as well. Right? So what you find then on the numerator, you get the product pairwise. That's what this is. This is the pairwise product, which is equal to this. And the denominator is a common denominator, which is the alpha beta gamma, which is a third, negative a third. All right, so let me shift this over so we can get a little bit more space again, because I don't have a lot of space to work with. So I'm just going to write what that is. Now remember now, what will happen is that this will end up being the pairwise product over one common product, right? When you put these together, it becomes the sum of these three things on top of one another. So I'm just going to write what it is equal to. But the pairwise product is this, negative 2/3. I'm going to put negative 2/3 over, and the product of the three roots is negative a third. Negative a third. So the negatives cancel, and the thirds cancel. So this answer is actually 2, you know. This actually works out to be 2. You see, we can make it a little bit smaller. Whoa, space a bit at all. It's smaller. Let's make it smaller. Right. So this equals 2. This is equal to 2. And the 2 is coming right here for the sum. All right. Then I need the product of the roots pairwise. When I pair them, these three roots, I need them. I pair them up, right? That's P2. The 2 means product by 2. That's my symbol that I use. All right. So P2, which is product when you pair them up, is 1 over alpha beta. We multiply these two plus 1 over alpha gamma. We multiply these two, and then plus 1 over beta gamma. We multiply these two. So those are the three pairs. And that is equal to. Now again, now I want the denominator to be the same. So I'm going to multiply this one by gamma over gamma, multiply this one by beta over beta, multiply this one by alpha over alpha. The net result is that you're going to get, this is gamma over gamma, right? So I'm going to get gamma plus, this one is going to become a beta on the numerator, beta, plus, this one is going to become an alpha on the numerator, alpha, and it's all over the same denominator of alpha, beta, gamma. Could have done the same thing with this. Let us do it. I'm going to just move these. Let us do it. And we can do math like little children, do like big children. Put the plus up there. And go like that. And put it over the alpha, beta, gamma. That's what you would get. You can make the denominator the same for all of these. All right? It will math at a higher level now. So this becomes the sum over the product, right? Of the original equation. So the sum is 1 over 3. 1 over 3 over the product of the three of them is negative a third. So this becomes negative 1. So negative 1 is coming right here, so for the pairwise product. All right. And then we have the product of the three roots, or the product of these three things. That's our P3. So P3 now, the product of the three roots becomes 1 over alpha, beta, gamma. You multiply these three things, that's what they're gonna get. Which is basically, you know, just 1 over this value, which is negative a third. So this really becomes -3. Become -3. So -3 is coming right here for that P3. So what we have to do is drop in the values and we get the equation. And this come out nice, so they're all whole number values. All right. So divide by a third is multiplied by 3. So the equation then becomes, it's the equation then that we want to find. This equation. Right? It becomes x cubed minus s, which is -2. -2 times x squared is plus P2. P2 is this -1. So I'm just going to put minus x. So I'm going to put minus x. And then it is minus P3. Minus becomes a plus, right? Because it is minus and -3, right? There, the P3 is -3. So your minus -3 becomes +3. +3. And that is equal to 0. And that's your answer. That's your equation right there. That has these 3 roots. The typical question. I said this all the time. And that's not the only way to do it. There are other ways to do it, but this way is good enough. Alright? That way is good enough. Alright. Next question. Next question is over here. Alright, interesting. I'm going to skip out anything. Alright, so far so good. This question says, boom bang. It says the diagram below shows a graph of this. So this is a graph that I give us right here, right? The quadratic graph. See across the y-axis at 8 right here. Whereas it cross the x-axis at 2 and -2 and -4, right? That's it. It's a smile graph. Right? That's the minimum point. That is, look at the scale. This is 1. This is -3. So this is -3, -1. That minimum point right there. All right. So that's basically making sure we can, see the scale and we can see what is what. And the y-axis going up by 1 as well. So everything is nice. All right. Let's see what I want us to do with it now. Let's see what I want us to do with it. All right. First thing I want us to do is on the axis provided above, which is the same axis, same graph, we want us to sketch and label the graph of g of x. What did they give us? They gave us f of x, right? Yes, they want us to sketch g of x. Oh, this is the modulus. Wow. So remember, the modulus is when you take the original. It's the same function, the same function, but the modulus, they put the modulus around it. All right? So it's a transformation of this graph, really, You have to transform this graph. But the modulus means that this part of the graph that is below the x-axis, all those y values become positive. And so it's just a simple reflection of that part over the x-axis under here. Let's say under the y-axis, under the x-axis. So this part of it, these values under here become positive. So function is going to go like this. So this part is reflected. So for example, this point comes to here. All right. So just a sketch. Just go like that. Bang. That's it. The rest of it stays the same because all the other positive values stay positive. So all of this now stays the same. I don't know if they wanted to draw over this, but this remains on the original. This original on the graph remains. So let me draw it in blue. Right? Let me draw it in blue. Everything else remains. Everything that is positive already stays positive when you put the modulus around it. Everything that is negative becomes negative. So let me put in this part of it. So what I'm drawing in blue is what the modulus, the g of x would be, which is a modulus. Alright, so that's what you have to do. I don't know if they actually want students to draw over this part, or they really just looking for this down here. But I want to write the g of x on this. Put the g of x right here. So this is my g of x, the modulus. Alright, and so draw it and label it. So that is it. Draw it and label it. Draw it and label it. So that blue graph is my g of x. Nice and easy. Alright. So this part no longer on it under here. So that is a part of f(x). All right, so that is that. Next part now says on the same axis, again, we have to sketch and label the inverse. And that's the original function of f is a many to one, can't have an inverse. So what they have done here now, they have restricted the domain right here, x greater or equal to -3. So -3 right here. So it means that they're taking this part of the graph, the majority in red. So they're only taking from here onwards, right? From this part of the graph onwards. Right? So I put in a circle here, that's where we start at -3. And you're taking the part of the graph that goes to the right. So basically that you're taking the inverse of the right part alone of the graph. Right? Inverse of the function for this. So talking about this part of the graph that I'm going to draw in red now. So that's stuff we're doing on the same graph, but I'm just doing it for the purpose of, this explanation. So this part in red becomes a function because this will make the function now one-to-one. Remember, only a one-to-one function can have an inverse. So the entire function as it is a while ago with everything cannot have an inverse because it is many to one. But now that they have restricted the domain, it is now a one-to-one. So this red part of it can have an inverse. And the inverse is formed by simply reflecting in the line y equals x. Now put in the line y equals x. And y equals x, just for illustration purposes, it will pass right down the middle, pass through 2, 2, 0, 0, 4, 4 right here, so, and so on, right? Pass through -2, -2, -4, -4. Remember now, the relationship between a function and its inverse is a reflection in this line, y equals x. You have to draw it with your ruler, all right? And when you finish reflecting, it should look like that this line is a mirror line. And it's kind of nice and friendly. Why? Because the x-axis and the y-axis have the same scale. When you draw a graph of a function that's inverse, you want the axes to have the same scale, right? Because the line y equals x is right down the middle now, and you're able to make it look like a real reflection. All right, so we're going to reflect that red graph in that line. All right, so what are the key things? This point here, that was -3, -1, is going to go to -1, -3, -1, no, it's gonna go to -1, -3, -1, -1, -3. Right? That's where it's gonna go. When you do a graph of function of inverse, that the coordinates flip around. So these coordinates, they flip around. Just coming to this point, -1, -3 is right here. So this point comes right here because it's like it reflects across, right across to there. All right. Well, this point on the x-axis will become a point on the y-axis. It's going to come across the line to here. So the point -2, 0 is going to go to point -2, 0 is going to go to 0, -2. So this point is coming right here. So I can put that point as well. All right. Another point we can pick up, yes, the y-axis intercept, which is 8. So that point up there would have gone to 8 over there on the x-axis, but that is not sure. All right, we can pick up any other point that we can. So maybe this is a point that we can use. What point is that? That point is -1, 3. Let's say that is -1, 3. Looks like -1, 3. So let's say that this point is -1, 3. We're gonna flip around and go to 3, -1, 3, -1. So that point is coming right here. 3, -1. All right. The graph finishing now. So where did it end up at 5? Right here says 5. On the y-axis, 5 was around when the y value is 5, it's like we're around this point. So this point is gonna come. This is like -1/2, 5. It's gonna go 5, -1/2. This point right here is like -1/2, 5. So it's gonna go to 5, -1/2, 5, -1/2 around here. So right, that's where it's gonna go. 5, -1/2. Hope you understand. Can't do this point because it's not shown on the graph. And then now you must turn away. So this turn towards the line, towards the mirror line, and then go like that. Same thing. Like you turn towards the mirror line first, and then you just go like that. And you just follow and go through these points, and that will be good enough right there. All right, so this point is the inverse of this point. Zoom it up so you can see. Let's zoom it up. This point is the inverse of this point. This point is -1, -3. And this point is the inverse of that point. Right? So we call the x-axis at -2, it now goes to y-axis at -2. That's what inverse does. And then this point here, we said it was, this point here was -1, 3. So it becomes 3, -1. That's the inverse point for that. 3, -1. Now that's what, those are the things they can do to sketch a proper graph. And this point here, where the y value was 5, because we know that we're going on to our x value of 5 down here. It's 5. I know the 5 is, yes, 5. Yeah, 5. Yeah, 5. The y value, the x value looks like -half. So that -half 5. So this point then is 5, -half. That point is 5, -half. All right. So basically, that's a sketch. I will put f of f to the -1 on it. So this becomes f to the -1. F to the -1 of x. That's the inverse. All right. So if you sketch those things, you get your marks in the exam. Easy. Nice and easy. 5 marks for that sketching. I say it's important to do it right. 5 marks for sketch a little thing there. All right. So you have to understand in order to do it. All right. And we'll put in line y equals x. Have you ever asked if the relationship between a function and inverse is this line? They are reflections of each other in the line y equals x. So this red part reflects to this red part and vice versa. Right, in the line y equals x. All right. Then we're moving along over here. All right, so this question now. It's a functions question. What a question long question one. Still on, you know, part B. Still question one, I'm going to question. Let me just check. Let me say still section 1 man. Let me question 2 man. Each question 2 already I never know because this is 3 now. Let me see when question 2 started. Let's see. We started right here with the function. Okay. All right. Didn't realize. All right. So when question 2, coming to the end of question 2. This is the last part of question 2 actually. Just want to know the questions along. Anyway, so they give us this function. It's a rational function, right? And it says we must prove that this does not exist. Prove that g of -2 does not exist. So it can be done 2 ways, you know. You can literally find the inverse of g and then show that g of 2. You can't find g of 2, it does not exist. Or we can set up an equation. I'm going to do it 2 ways. We can set up an equation and say, okay, do it 2 ways. I'm going to say, let g to the -1 of 2 be equal to some number. I want to see if we can actually find that number. Right? Let's see if we can actually find that number. And they are telling us that the inverse exists. So once the inverse exists, it means that the 2 will be equal to g of n. If g to the -1 of 2 equals some number n, then it means that the g of n is equal to 2. That's relationship. Is that almost like we bring the inverse of g over here and make it just g. All right. So like we're now solving this. So like we're solving g of n equals 2 and see if there's an n value that will cause g of n to be equal to 2. All right. That's what we're solving this now. So g of n equals to, what would g of n be? We can set up this way now. The 2 will be equal to g of n. What will be g of n? It will be 2 times n plus 3 divided by n plus 3. And we're trying to solve for n. Like we're trying to find if there's an n. Then the n exists for g to the -1 of 2. So I'm going to multiply this across here by the 2. I'm going to get 2n plus 6 equals 2n plus 3. And voila. So what does that mean? The n is being eliminated. And you get something that is not true. 2n minus 2n that gone. And you're getting 6 equals 3. Which is not true. This is not true. This is not true. You're getting something that is not true. Because I get in something that is not true, we can therefore conclude that g to the minus 1 of 2 does not exist. I think that's a good enough way to do it, 4 marks. Or let's do it another way now. We actually find the g to the minus 1 first. So we can say or, let's do it another way. Or what we could do is find the g to the minus 1 first. So I'm going to start by saying g equal that and do the inverse. I think it's a longer method this, you know. We're going to put g equals 2x plus 3 over x plus 3. So what is going to happen is that your g to the minus 1 is going to have x minus 2 on the denominator. That's what's going to happen. And we want to form the inverse function. When we form the inverse function, the g becomes x. And the x here and here, each becomes g to the minus 1 in the inverse function. 2 g to the minus 1 plus 3 over g to the minus 1 plus 3 again. Eh? So like we're solving for the g to the minus 1 now. Just going to multiply this over here first. And so we're going to get x times g to the minus 1 plus 3x equals 2 times g to the minus 1 plus 3. I'm going to take this g to the minus 1 over this side and subtract it. And take this 3x over that side and subtract it. So I'm going to get x g to the minus 1 minus 2g to the minus 1 equals 3 minus 3x. Because I take this 3x and bring it over here and get minus 3x. I take this g to minus 2g to minus 1 and bring it over here and get minus 2g to minus 1. I'm going to factorize the g to the minus 1 out of these two terms. So I'm going to get g to the minus 1 into x minus 2 equals 3 minus 3x. So then I'm going to get g to the minus 1 equal 3 minus 3x over x minus 2. That is really g to the minus 1 of x. And I'm going to put in of x back now, of x. So if you're trying to find g to the minus 1 of 2 now, so you can say therefore g to the minus 1 of 2 becomes 3 minus 3 times 2 over 2 minus 2. 2 minus 2. This one here says 0. That is an undefined quantity. Undefined. They can't divide by 0. That is undefined. Undefined means that it does not exist. It is undefined. So g to the minus 1 of 2 is undefined. Undefined. Spell right. Like it's spelled right. But that is it. Right? Undefined means does not exist. Does not exist. I think this over here is a nice cool way to do it. You can pass. But I don't talk about find the inverse first and all of that. I think this is it over there. Alright? Show that there's no n. So when g to the minus 1 equals g to the minus 1 of 2, there's no solution, no real solution. But this is not true. Alright? Good. Let's continue. Oh, that finishes that question. So on to number 3 now, which is trigs. Trigonometry. Trigonometry. Rather than doing this for you, doing this for you. Already. So must prove that this equals that. Alright? We have a perfect square inside here. So alright, so when you know the trigger, when you know your trigger identity, these things become very easy, you know. They become very easy. In my mind, I'm seeing this as 1 over cos. And I'm seeing this as sine over cos, which really is 1 minus sine over cos. Right? So I want to get that in this. So to get that over here, I know, and it's under the square as well. So it's almost like I need to get a cos squared theta on the denominator. So this needs to become a cos squared. This is already a part of cos squared. Because I know that 1 minus sine squared theta is the difference of 2 squares. It equals cos squared theta, but itself is the difference of 2 squared, 1 minus sine theta times 1 plus sine theta. So that this is a part of the factor that will lead me to a cos squared theta. So I'm just going to multiply the left side. I'm going to take the left side. I'm going to multiply and make the denominator become a difference of 2 squares. So I'm going to multiply the numerator and the denominator by 1 minus sine theta. All right, so I have the 1 minus sine theta. Let's write it back. over the 1 plus sine theta. And what I'm saying I'm going to do, I'm going to multiply the numerator or the denominator first by 1 minus sine theta, and then multiply the numerator also by 1 minus sine theta. Right? So already I have a perfect square on the numerator. So already know. So this becomes, I'm going to keep it in. I'm not going to multiply it out because I want this perfect square here. So I'm going to keep it as 1 minus sine theta all squared over. Then this and this now will becomes cos squared, you know, as I show over here now. You could actually leave this on the paper, you know. You can actually leave this on the paper, right? So that you're saying basically that 1 minus sine, 1 plus sine times 1 minus sine is actually 1 minus sine squared, which is cos squared. So you could leave that on the paper, right? So the denominator really becomes cos squared. But let's write it out first. It becomes 1 minus sine squared theta first, which is cos squared theta. So I have 1 minus sine theta over, when this is a square, sorry, over cos squared theta. Then because this up here is a square and this under here is a square, I can put both of them under the square. I will put 1 minus sine theta over cos theta all squared. And see, I've generated my perfect square from up there. And then now, I'm dividing each of these. I'm dividing this by the cos theta and dividing this by the cos theta. So I get 1 over cos theta minus sine theta over cos theta all squared. And then 1 over cos theta right here, so it's sec theta. And the sine theta over cos theta is tan theta all squared, which is the right hand side. And that was an easy 9 marks. Wow. Okay. That is it. When you know your trigger identities in your head, these things, they become super, super easy. I tell people all the while, put the trigger identities in your head. Study them, know them, left to right, right to left. You want these things to become easy, put the trigger identities in your brain. All right, make them stay in your brain and they will work like a computer and just tell you which one you need to use and you see your way through easily. As you see the proof, you know the steps that you need to take, generally speaking. Right? But the first thing to make these things easy is to actually know the trigger identities. Don't depend on the formula sheet for trigger identities. You have to get them in your brain, get all of them in your brain. Take time and learn all of it in your head if you really want to be good at this thing. All right? Next question. Next question right here is to solve this, a typical question, right? So typical question where I can change this cos squared into sine squared because I can't change the sign. So this is going to become a quadratic in sign. Let me write what I'm going to use first. I'm going to write that the cos squared theta is actually 1 minus sine squared theta. That's what I'm going to change this to. And it's 2 of that I have. So it becomes 2 of this I'm going to get. All right? So I already know. So what it means is using that identity, this equation is going to become 2 of this is 2 of this. So it's going to become 2 minus 2 sine squared theta. That's what the cos squared becomes, you know. And your mind is theta, no, it's x. Sorry, it's x. Not theta, x. X. So this should be, no matter still about, this should be x. It don't really matter about. So just keep it. This should be x. This should be x. All right, so it's x. Boom, bang. So I'm bringing back this part now. So I have minus 3 sine x and equals 3. I want my square term to be positive, so I'm going to transpose everything over onto that side to get my square term positive. So when this goes over that side, it becomes a positive 2. So it becomes 2 sine squared x. This goes over there and becomes positive as well. It becomes positive plus 3 sine x. What happens now is that this 2, when it goes over there, it subtracts from the 3 and give me 1. I'm going to get a plus 1. And that will be equal to 0 over here if I transpose it. But I can put the 0 here on this side instead. because it's the same thing. And so I know I set out the equation, my normal rates are quadratic. And these are prime coefficients at the end. And that prime, and this is just 1. 1 is not a prime number, but you know, all the factors of 1 we can have is 1 and 1. And everything positive, so it becomes very easy. So when I factorize this, everything is positive. I'm going to get 2 sine x, and 1 and 1. And signs are the same, they are both positive. Everything positive. And it works. The far product is 2, the near product is 1. They add to the 3 middle term in the middle, right? So you know that the factorize is good. This is all equal to 0. So you're going to get sine x equals minus half. You're going to get sine x equals negative 1. I was solving in this range, full quadrant diagram of solving. So I'm going to draw the quadrant diagram for this first. All right. And I want where sine is negative in both cases. So I'm going to draw the quadrant diagram like this. I want where sine is negative. So I want these two quadrants where sine is up and angle is negative. Sine is positive in those two. I want where it is negative. The principal angle for a half, everybody must know that sine of a half is 30 degrees. 30 degrees is pi by 6. So the principal angle is pi by 6, which is sine to the minus 1 of the positive value here, which is a half. So that alpha is pi by 6, pi over 6. Some character will give you one equivalent of pi over 6 in this quadrant and this quadrant. What are you going to know? This quadrant is my pi plus alpha quadrant, and this quadrant is 2 pi minus alpha quadrant. So I can write my values over here. So my theta over here, not I keep writing theta, it is x. So my x over here in this quadrant becomes pi plus pi by 6. The alpha is pi by 6, remember. And this quadrant is 2 pi minus the pi by 6. Let's just write what they're equal to from now. X equal. Well, this is the same as 6 over 6. 6 and 1 is 7. That becomes 7 pi by 6. 7 pi by 6. And then this one now, this same as 12 over 6. 12 minus 1 is 11. Right? 2 is the same as 12 over 6. That's 11 pi by 6. Right? Those are two values. Then we'll come to this one now. I have to solve that as well. So we're going to draw the quadrant diagram for this again. So one angle you're going to get, sine of 270 degrees, 3 pi by 2. You have to know those things. Right? Sine equal negative 1 only when the angle is 3 pi by 2, 270 degrees. But follow the process and to lead it to it. So the first I want where sine is negative, which are these two quadrants again, here and here. And to get the principal acute angle alpha is going to be pi by 2. We're going to do sine to the minus 1 of the positive 1 of this, the positive 1, which is 90 degrees or pi by 2. So one equivalent of pi by 2 here and equivalent of pi by 2 there are going to work out to the same thing, because it's going to be pi plus alpha is going to be 2 pi minus alpha. So the angle is just going to be the same thing, right? Because this pi plus alpha cannot work it out right here. All right, let's write it. The x becomes equal to pi plus pi by 2, but the alpha is pi by 2, or 2 pi minus pi by 2. Both of them is the same answer. This is the same as 2 over 2. It becomes 3 pi by 2. 3 pi by 2. Well, this is also 3 pi by 2. I want to know because it's the same as 4 over 2. 4 minus 1 is 3. So I said the only angle where the sine is equal to negative 1 is 270, which is 3 pi by 2. That's when you go around the circle the first time. So this is also 3 pi by 2, which means that angle can only be 3 pi by 2 if you're going between 0 and 2 pi. And then you have to put these answers in ascending order now, guys. So it becomes x equal. So if this was in terms of pi by 6, let's write it. It's x equal, multiply it will be 9 pi by 6. If you write, I want to reference that. So the solution line, the solution is x equal, the smallest one is this, 7 pi by 6. We have 9 pi by 6, which is 3 pi by 2, right? 3 pi by 2. And then you have 11 pi by 6. And these are your answers. 9 marks for that, total of 9 marks question. That's it. Easy to choose. This question can come at hard maths, you know. Hard maths level work this. Alright, over here now. Another hard maths level work. Show that this equals that. I'm not gonna do it the easy way. Alright, I can do it a neat way, you know. Right, by using complementary angles, you know, but I can just expand this. So I think maybe that's what they want. So I'm gonna write the left hand side equals the expression of cos is cos, sine. So it becomes cos of pi by 2, cos of x. Since I have a plus here, you're gonna get a minus in between them. Minus sine now. Sine of pi by 2, sine x. Easy way to do it. But the cos of pi by 2 is 0. Cos of 90 degrees is 0. So it becomes 0 times cos x. Minus, this is 1. Sine of pi by 2 is 1 times sine x. This is 0. So you end up with minus sine x over here. That will show that is the right hand side. Quite easily done. That's it. 4 marks for that. Easy question. See, said add maths could be at this as well. Alright. I think actually this common add maths multiple choice, I'm sure. Right, but add maths, this is add maths level work right here. So far the paper easy, you know. The people say it really started to get nice over in section or model 3. All right, let's go. Another easy question here. It says A and B are acute angles. So in the first quadrant, so it means that sine, cos, and tan positive. All right. So sine A is this, cos B is that. Easy question. It's a 3, 4, 5 triangle. It's a 5 to 13 triangle. So can I tell you just sketch 2 triangles? Just sketch 2 triangles to represent information. Angle A, sine is opposite of hypotenuse. This is 3, this is 5, so this side is 4. So 3, 4, 5 triangle. Everybody must know that. Then the one for this one, also acute. So no negative or anything coming into play there, because the angles are both acute. This angle is B, then it's cos. Cos is adjacent to hypotenuse. This is 5, this is 13. This side is going to equal 12 if you use Pythagoras theorem. They cannot penalize you for advanced knowledge to write down these things, right? Because everybody knows 3, 4, 5 triangle and 5, 12, 13 triangle, right? If you want to show some work for here, you can do it. So for example, you can just write that this becomes the square root of 5 squared minus 3 squared. Pythagoras theorem, right? And this one over here becomes the square root of 13 squared minus 5 squared. That's what it is using Pythagoras theorem. So if you want to leave it on the paper for them to see where you get the 12 and 4, fine. What it means now is that we can work this out now. Cos of A minus B. So remember it's cos, sine. So we're going to do now. So therefore, cos of A minus B. Easy question, this man. Cos of A minus B. This again could be an odd math. So for some odd math question, I say for the tricks, you know. It's cos, sine. But because this is a minus, I'm going to put a plus in between them. Cos, sine. So it's, let me shift it over. Cos, sine. So I'm going to write cos A, cos B. Because this is a minus, I'm going to put a plus in between them. So I get a plus sine A, sine B equals, what is cos A? Cos A on this triangle is adjacent over hypotenuse. That's 4 over 5. What is cos B? Cos B, what they gave us, 5 over 13. Plus, what is sine A? Sine is what they gave us, 3 over 5. What is sine B? Sine B is 12 over 13 on that triangle, opposite over hypotenuse. So it's 12 over 13. Now 5 times 13 is what? 65? Yes. And 5 times 10 is 50, and 5 times 50, 5 times 3 is 15. So this really becomes 20 plus 36. 4 times 5 is 20. 3 times 12 is 36. That's 56. Let's make sure. Right? 20 plus 36. Yes, that's 56. 3, 12, 36. That's 56. I get 56 over a common denominator of 65. 65. That's the answer right there. I've got a 5 times 30 is 65. All right, that's done. Let me shift it back up a bit. Easy question. So far, these questions so far in the trick part, come on, add maths level work. All right, number 4 now. Number 4. All right, so give us 2 parametric equations here. Typical question. They want us to obtain a Cartesian equation. So we have to use a trig identity that says sine squared plus cos squared equals 1. That's what we're using now. From this one, you can see that the cos of t is going to be x over 3. From this one, you're going to see that the sine of t is going to be y over 4. What do we know? So we can say now cos squared t plus sine squared t is always equal to 1. So the square of this plus the square of this is equal to 1. Done. So x over 3 squared plus y over 4 squared is equal to 1. That's it. And this equation, let me write it better. Let's x over 3 squared plus y over 4 squared is equal to 1. That's a Cartesian equation. You get the Cartesian equation where you eliminate the parameter. T is a parameter. That's the way to do it when you have trigs. Cos and sine. If you have tan and sec, you would use 1 plus tan squared t equals sec squared t. Sec squared t. It was tan and sec. It was cot and cosec, you'd use 1 plus cot squared t equals cosec squared t. You have to know your identities. When you know them, everything easy in trigs. Once you know your identities, everything easy in trigs. All right, but that is it. All right, I won't even change anything. Let's leave it like that. Believe I won't even change anything. That's good enough. Once you get rid of your t, you go. This is a key step right here. This key step. All right, next question. The one here says, oh, this is some vectors now, right? 3D vector. This says the equation of our line is x equals 2 plus t, y equals 1 minus 3t, z equals 4 plus t. So give us that line in parametric form. That's what we call parametric form. It says the equation of our plane is this. That's the equation of our plane. It says determine the point of intersection of a line with the plane. So the determine point of intersection of a line and a plane, you substitute the line into the plane. That's all you have to do. Substitute the line into plane. So you substitute this for the x right here. Substitute this for the y right there. And substitute this for the z right there. That's all you have to do. Find the t. And after you find the t, you plug the t back into these and get the coordinates. As easy as that. So we're going to sub the line into the plane. Sub line into plane. So the line equations into the plane equation. That's what I mean. Sub line into plane. We're trying to find the t. So the equation here now is going to become 2 plus t. That is the x plus 2 times. The y is 1 minus 3t. Plus the z is just 4 plus t. And all of that equals 12. 12 right here. So I've substituted these into this equation for the x, y, z. And we're trying to find the t. After I find the t, we'll know the individual coordinates for the point. Let's add it up now. All right. We can add up these two to go. And then 2 times. We cannot do it straight enough. Let's just do it straight. So the t is first. This is t minus 60. I'm going to go step by step. Add up these two first. These two can be added together. Expand this and add these two. All right, let's go. So this becomes 2 minus 60. and then this and this will be 2t plus 4, because it's 2 or 6 plus 2t. 4 and 4 is 6 plus 2t, all that equals 12. So this and this is minus 4t. So it's minus 4t we have, and then this and this is 8. The 8 goes over there and subtract from the 12. Let's write this better. Equals 12. Right, so this and this is 8. We go over here and subtract from the 12 and become 4. And so t equals -1. If t equals -1, it means that the z, so we can say therefore the z, no, not the z, first the x first. The x equals, from right here, so 2 minus 1, which is 1. The y equals, plug the t in here again. 1 minus 3 times minus 1. That's 1 plus 3 is 4. And the z equals, plug it in here again. It becomes 4 minus 1. 4 minus 1, which is 3. So those are the coordinates. Therefore, the point is, the point that they asked for is x, y, z. 1, 4, 3. X, Y, Z. Easy question. Easy question. That's it. All right. Solve the equation of a line and a plane simultaneously. Substitute the line equation into the plane equation. So you put them in parametric form first. And you find the t, you substitute the t back into the individual parametric forms, and you get the line. Let's just double check it. So the t is -1. Yeah. And the 2 minus 1 is 1. Then minus give a plus 3, right? 1 plus 3 is 4. Then 4 minus 1 is 3. All right, so that is correct. That is the answer. Just double checking. All right, let's go down here. Oh, more vectors. Usually, must give one little vectors and done enough. Even more vectors. Oh, wow. This one said determine the equation of the plane which passes through this point. So this point is our A, and it's perpendicular to this. So this is our N. Easy question. The plane is A dot N, no, R dot N. Wow. R dot N equals A dot N. That's the equation of the plane. That's the equation of the plane right here. So the R, and it's a vector equation, so I have to leave the R in it. All right. So it becomes R dot, and the N is this. 2, 4, 3 equals, the A now is this, of this point is 1, 5, -1 as a quotient vector of that point, dot N. This N is 2, 3, 4, just the same, right? 2, 4, 3, wow. 2, 4, 3, 2, 4, 3. So it becomes R dot 2, 4, 3 equal, and I'm working out the scalar product now. So 1 times 2 is 2, 5 times 4 is 20, and then -1 times 3 is -3. So we end up getting R dot 2, 4, 3. Let's write that better. 2, 4, 3 equal, this is 22 minus 3. It's about 19. Yeah, 19. 19. This is 20 minus 3 is 17. 17 and 3 is 19. Right, so this is -1. 19. So that's the equation of a plane enough. You can also write it like R dot, and then you put 2i plus 4j plus 3k equals 19. Since it's a vector equation, I can give them, but we could leave this enough. Why? Because they gave us in that format. Right? So we could leave that. That's the vector equation of the plane. So no, hence means that we must use that result, right? Hence, determine the coordinates of the point with the plane, determine the coordinates of the point on the plane where y equals 3 and x and z equals 1. Simple enough. All right, so what it is that you see this? It's a general that represents all points on the plane. So this equation written in terms of coordinates, can be written as x, y, z, because the R represents all points on the plane. And that's what the R represents. All points on the plane. Dot 2, 4, 3 will always be equal to 19. So scalar product between any point on the plane and the normal will always be equal to 19. That's what it's all about. And they give us 2 of the coordinates on that point already. So how much space we have? So we can say at y equals 3 and z equals 1. It's just the x value we don't know. The x3, 1 dot 2, 4, 3. 2, 4, 3. 2, 4, 3 will be equal to 90. I'm trying to find the x. Trying to find the x now. Alright? We want a space. Make this smaller. Make this smaller. Let's make it smaller. Smaller. Right here. And let's shift this over here. Make it smaller and shift it over there. It's smaller. Shift it over there. Alright? So we're using this right to put in for equation in a different color. Alright. And then we're doing our work right here now. Because what it means, as I said, this becomes the equation of a plane. We write it as coordinates, right? And they give us these 2 coordinates and the point that we want. So plug them in the points in the point for the plane. I'm just trying to find the x. Wow. Just trying to find that x. So already know. So when we multiply the scalar product, so it's 2x times 2 is 2x. 3 times 4 is 12. 1 times 3 is 3. All of that is equal to 19. What is the x? This is 15. 15 go over there and subtract, give me 13. So 2x equals 3, not 13, 3. That is 15 go over there to subtract 18, give me 3. So the x equals 3 over 2. The question is to find the coordinates of the point. So the point then. And coordinates written like this. This is the x value. 3 over 2. And they gave us this as our y value, 3. And this as our z value, 1. That's his answer. That is the point. Easy. Easy. Easy stuff. These questions so far don't require nothing thinking enough. Straightforward. No thinking. We don't get to the second part yet. So far, easy. This question, no. Wow, more vectors. Normally, you just get one little vector, you know. Instead of us change. It says, given the line, given that a line is parallel to this, so a line that is parallel to this have the same direction as that, right? And that the vector v is a normal. That vector v is a normal to a plane, to the plane. Normal to the plane. Calculate the angle between the line and the plane. Wow. So there's an angle between a line and a plane. So they're basically helping us, you know, between a line and a plane. So there's actually a formula for it, you know, similar to the scalar product formula with the cos. But what does that mean? It's going to use it with a sign instead. Let me sketch it for you and show you what does that mean. Let me sketch it and show you. So it's like, let's draw this as a plane, right? Let's draw this like this, a plane. Kind of convenient to draw it this way. Let's say that that is the equation of a plane, right? And then now we have the normal. Let's use some different colors. So this is the normal to the plane. Let me draw this better. It's not look so horizontal. Let's go again. So let's say this is our plane. What space we have? Or what a space. All right, so this is our plane. Like this. I'm sketching it. This is our plane. And draw the normal like this. Let's say this is a normal to the plane that they gave us, right? They gave us a normal. They tell us that this is a normal, right? The vector v is normal. So this is the vector v. Normal to the plane. Right? Let's put the v on it. And that's the plane they're talking about, right? And then they tell us a line now. They tell us about a line. Let's draw the line in. Let's draw the line in red. I draw the line in black. The line U, or the direction of the line is parallel to that, so no matter. In vectors, line and direction is the same thing. A direction is a line, and a line is a direction. So I'm going to draw this U like this. Bam. That vector U. So this is our vector, the direction of that vector U, right? Same direction as the line that we want, U. And the question is asking us for the angle between the line and the plane. So the question is asking us for this angle here. This angle here, so alpha. That's the question asking us for now. Angle between the line and the plane, alpha. Angle between the line and the plane, alpha. What we're gonna do, we're gonna recognize that because this is normal to the plane. And this angle right here says 90 degrees. Right here is 90 degrees. And so it's like we have a right angle triangle here, so working. And then this angle now becomes convenient for us to find. So this angle, we call this angle theta. Zoom it up and call this angle theta. This angle right here, now we're going to call it theta, which is the angle between the normal and the line. Which is really alpha we want to know. But guess what now? Alpha and the alpha that we want and the theta, they are complementary angles. Right? And what do we know? The angle between the line and the normal and the line. We can use the scalar product formula to get the theta. What would that mean is that the cos of theta. So like we can do it two ways, you know. We can find the theta first and then subtract it from 90 to get the alpha. We can do it that way. There's really alpha we want. Right? But the method would be, you can set up like this. The cos of theta, right, will be equal to the scalar product over the modulus product. It will be equal to v dot u over the modulus of v times the modulus of u. The cos of theta is a sine of alpha, you know, because they are complementary angles. Let's put it over here. Right? The cos of theta will always be equal to the sine of alpha, complementary angles. And it's really alpha we want. Since I put cos of theta here, so you can just put sine of alpha here. That's the same thing. And so since this is the cos of alpha and sine alpha is the same, that now will be equal to the v dot u over the modulus of the v times the modulus of the u. And we just need to solve this for the alpha. Good. Right? So the alpha is going to be sine to the minus 1. So we normally have cos to the minus 1 becomes sine to the minus 1 of this now. What is u dot v? Scalar product between these two vectors, right? Scalar product. Let's just write it out now. Bang. Scalar product over modulus product. Scalar product is 1 times 1 first, which is 1. Then negative 3 times 2, right there, negative 6. Then 1 times 1 again is 1. Over the modulus now, product of the modulus. This one first becomes the square root of 1 squared plus 3 squared plus 1 squared. That's this one we just did. Alright, I put v dot u, I'm just change them on. Alright, u dot. That's, I'm working on the other way around. It really matters still now. Just that I'm doing the u first. So I'm going to write u dot v over the modulus of u and the modulus of v. Modulus of v. And put u dot v again. U dot v for the modulus of u, modulus of v. And I have already have the calculation for the modulus of u under there. Now I need to do the modulus of v, which is 1 squared, 2 squared, 1 squared, and that. 1 squared, 2 squared, 1 squared gives us the modulus. I'll just write this to completion now. Alpha is sine to the minus 1 of, this up here so becomes a negative 4, right? Negative 4. Right? Negative 4. Negative 4. I don't like the fact that we're getting a negative over. This now becomes 9 and 2. 9 and 2 is 11. So we get the square root of 11. And then this now becomes 4, 1 and 1. Square root of 6. 4 and 1 and 1. Square root of 6. So this is really square root of 66. That's what we're getting. All right. So the sketch is not a true reflection of the actual situation, but it helps to understand the approach, the process to find it. All right. So let's just calculate this now. Alpha equals sin to minus 1 of that. I don't like the fact that it comes out negative, but it will come out negative based on those values, right? Because it's negative 3 times 2 comes out what it is. So we're doing sin to the minus 1, sin to the minus 1 of sin to the minus 1 of negative 4 over root 66. I multiply the 11 and the 6. And then let's work this out with the calculator. Let me see what I get. Here's my calculator. Let's do it the way you're supposed to see what we get. Calculator. Wow. Here are you. Here you are. Alright, so I'm going to put it in degrees, yes. I'm going to sin to the minus 1 of a fraction, negative 4 over root 66, root 66. We get negative 29 degrees in that, guys. Yeah, the negative is just a matter of which side it's on. Minus 29 degrees, 29.5 degrees. So the negative really is about direction. It's really about which side it is on, right? Because it could be that it is the angle the calculation given us. This angle. So I put the negative 29. We could also do 180 minus. Like we're taking an angle in the second quadrant, right? So do 180 minus. So we can say alpha. Alpha comes 180 degrees. So we want to put the negative minus 29.5 degrees to get that positive angle. And subtract this from 180. 180 minus. It's going to get 180 minus 29.5. We get 150.5 degrees. So it could be that the calculation is giving us this angle here. All right. This diagram is not the true thing, you know, so you have to bear it. Just a simple sketch to give it. I remember scalar product has to do with diverging vectors and converging vectors. So maybe what it is that realistically, this is actually going in this direction, this way. All right, and so the angle between them will be this one out here, something like that. All right, so or about to go. I think they'll accept either one, 29 or whatever. And then even the 105, 150.5. They didn't say acute or anything like that. I noticed they didn't say acute or anything like that. So the answer that we got could be like that angle over there. All right, between the vector and the plane. All right, so that is that question. All right, we can give what the numbers give us. That's what the numbers give us. All right, next. All right, so we're on to number 5. There's 2 questions left. 5 and 6. I don't know how long we're going. Wonder how long the matter still. I'll finish it for Jordan and future students. All right. Wow, they start to give those kind of limits now. We call them improper limits. I think it's improper they call it. Improper. I don't know what they call it, but no matter. When you're solving this to infinity, you want to recognize that 1 over infinity is 0. That's what we're basically trying to use. So what you do with this expression, you divide numerator and denominator by the highest power of x, which is x to the 4th power. They want to create some 1 over x situation, so that when you plug the infinity into it, those terms become 0. All right, 1 over infinity is 0. So you're going to divide numerator and denominator by the highest power of x, which is x to the 4th power. Let me write here so in bracket. You're going to divide numerator and denominator by x to the 4th power. Just write it here. So when I write it here, I don't mean one side, numerator and denominator. So my limit becomes equal to the limit as x tend to infinity This, when I divide by x to the fourth, becomes 2 over x. That's right. It becomes 2 over x. By this one, it becomes negative 4 over x cubed. But divide it by x to the fourth over x cubed. Plus, this becomes 1 over x to the fourth. It's going to be 0 in a man. It's going to be 0. And somebody starts 0. So that's 0. But this power so big. It's just 0 in a man. It's going to become 1 over x to the fourth power. All over. This is going to become 3. This is going to become 1 over x squared. This is going to become minus 2 over x to the fourth power. All of this is 0 now. Equals. This becomes 0, this becomes 0, this becomes 0. Really? So you get the limit. It becomes 0 when you apply the limit. Okay, you get 1 over infinity, 4 over infinity. You get 0. So you get 0 numerator, 0 plus 0 plus 0 over 3 plus 0 plus minus 0. Minus 0. The answer is just 0. 5 marks to that. Oh, yeah, that is it. Answer is 0. Unbelievable. Yeah, should I know because the highest power was on the denominator. Okay. So it's going to become 0. Yep. 0. Divide by x to the fourth. This becomes over x. This becomes minus 4 over x cubed. This becomes 1 over x cubed. Each of these becomes 0. You put infinity under here. And like divided by an extremely large number. Alright? That is it. Anyway, the answer is 0. Alright, let's go. Next question. Oh, on the next side. Remember I'm going across here. This question now says, let's see this one, what it says. It says a student goes to a water cooler to get a drink of water. The student has a cup in the shape of a cone. I get this is a cone, right? The water from the cooler is filling the cup at a rate of 12 cm cubed per second. All right, so this is a connected rate of change. So the information here is that dV by dt, that's the rate of flow of the water, is 12 centimeter cubed per second. S to the minus 1, right? It's a constant rate of flow. It says if the height of h of the cup is 16 centimeters and the radius r of the circular opening is 8, so them short here, so it's 8. How fast is the water in the cup rising when 8 equals 4, when the height is 4? All right, so this is a question we need to have the height bearing. So that the putting water in the cup and it is rising. So what will happen is that eventually it will get to a height h that we have to indicate. All right, it's gonna get to some height h. All right, some height h. And when it gets to that height h, well, let's not call it h, let's call it y. Since we call it the original height h, let's call it y. You can call it h, man. Them give us r and h, no matter. We can call it h still, no matter. This is the height over r. So ignore that h and ignore that r. We're just gonna call the variable height h still. We don't want to confuse ourselves. And let's call the variable radius r. The variable radius here we're gonna call it r right here. R. Now what happened is that we have similar triangles in here now, guys. So if I put the h inside here for the height that we're using, we have similar triangles. Right? If I were to pull it out and show you, it's like a similar triangle here. So let this focus on it. And then we have this piece right here, so, right? So the overall height is 16 up here. And over here is 8. And then this is our R. And this is our H. We're using R and H. So those are similar triangles. This triangle right here, so similar to the big triangle. So it gives us a relationship between the R and the H. All right. So the ratio of corresponding sides equal enough. So for example, we can say the H over the R. The H over the R will be equal to the overall height of 16 over that of 8. It will always be 16 over 8, which is 2. So it means that the height will always be 2 times the radius. The overall height is 16 and the radius is 8. The height will always be, there's no 2 times the radius, and the height is 16 and the radius is 8. Where the water reach, the height will always be 2 times the radius. That's a relationship between the radius is half the height. All right. So we need an expression for the volume of the water there, because what the question is asking us for here is the rate of change of the height, which is really dH. This is how fast is the water rising up the cup. This is asking us for dH by dt. That's what this is asking us. How fast is water rising up the cup, rising in the cup? That is dH by dt. Let me write it smaller. Right. They're asking us for dH by dt. We don't have any direct formula connecting H and T, so we have to connect the rate of change that we have. So they even tell us the volume of a cone here we need it, but the H is changing, R is also changing, but then there's a relationship between them. So let's set it up now. Volume. So we have this already. We're going to use this in our rate of change. We need to establish a relationship between V and T, so we can connect V and H, so we can get dV by dH. We're going to need it. So the V right now of the cone, water in the cone, is 1/3 pi r squared h. I think the sad thing with this question is that they put the r here and h here on the dimensions. They should not have done that. They should not have said r equals 8 and h equals 16, right? Because r is varying and h is varying. We're talking about the height of the water. They should not have called the overall height and the overall radius r and h, right? That can throw off the students. But anyway, all right. So I've used the relationship, and it is the h that we're interested in now. So it means that we need to substitute for the r. So from down here, the r will be equal to h over 2. So we'll take this h over 2 and substitute for the r right there. All right, we're gonna need is the h that we're interested in, because they say the rate of change of the height when the height is 4. So we're not interested in the radius. So we have to get rid of the radius out of the relationship, right? So I substitute for the h over 2 right there. So we're gonna get that the volume equals 1/3 pi times h over 2 squared times h. So it's gonna become, we're gonna square this 2, and gonna become 4, and the 4 times 3, so it's 12. So we're gonna get 1/12 pi h cubed. That's what we're gonna get. We're gonna have to differentiate this. So we know that dV by dH, we're gonna need it, is 1/4 pi h squared. All right, we're gonna need to connect these two rates of change to get what we want. But what do we want? We're required to find rate of change of the height dH by dt. Let me make it smaller. Let me zoom it up and make it smaller. So we're required to find dH by dt. That's what we want to find, the rate of change of the height of the water. We don't have any formula connecting them directly. So if I set up the chain rule, multiply 2 rates of change. The dH go on top of the first fraction here. That's how we can set it up easily. The second variable goes on the bottom of the second one. This is the dt. The third thing that is changing is the v. The v. So we're gonna put the v here and the v here. We know this now. They gave us that the dv by dt is 12. And then now, this dH by dV really is reciprocal of this. dv by dh. Let me zoom it up. This dh by dv that we want is the reciprocal of this. All right, let me write this as a fraction then. Let me write this here as a fraction. So since we're going to need a reciprocal. So it is really then pi h squared over 4. It is pi h squared over 4. All right, let me pull this down a bit. All right, so I'll pull this down a bit. I'm doing this for Jordan. This is D. All right, so I'm going to put in the values now. So I'm going to get dh by dt equals, if this is dv by dh, then dh by dv is the reciprocal of that. I'm just going to put it right here. 4 over pi h squared. Hope you understand that, times. And this was 12. They gave us that at the beginning. That is 12. So multiplying this by 12. And it's when h equals what? They said when h equals 4, right? They said that they want it when h equals 4. So this is when h equals 4. That's what they said. And the height is 4. See? And the height is 4. Don't like how to set up this question because they put the r and the h on this diagram. Some students might not even know how to move. Remember, you have to be smart. When the height is 4, so you're going to put the 4 right here, so. And that's how you're going to get the answer. All right. What do they want in terms of pi? They say anything like that? No, we're just going to put in the 4 and calculate it. So it's going to be 4 over pi times 4 squared times 12. And the height is in centimeters, right? Let's see. Centimeters, yeah, because it was cm cube. So centimeters per second, yeah, 4 centimeters. Just need to work this out and we get the answer. All right, work that out and get the answer. Let's see. So it's kind of easy, you know. It becomes, you can just write 3 over pi now. Because what happened is that 4 into this, cancel one of that, and then the 12 over 4 is 3. So just 3 over pi. And leave it like that, not exact. So it becomes 3 over pi centimeters per second. That is the answer. Nice question. I like it a lot. This was a nice question. It comes on to a nice easy answer like that. Over pi centimeters per second. Leave it as an exact value like that. Yep. Let's go. Next question. This is for Mr. Jordan. Mr. Jordan. Let's see this one. It says a manufacturer of containers wants to make a container in the shape of a cuboid with an open top. The container is made from a flat sheet metal of length 16 meters and width 13 meters. It says squares of length x meter are cut from each corner of the sheet to create the size of a container. I remember a question like this from GCE years ago. Yep, it's like a couple CXE couple this question. Show that the volume is equal to this. Now let me show you what is that. I'm gonna remember this question from CSEP years ago. So it's from GCE. So it's like you have a sheet of metal, right? I think in GCE they actually draw the diagram for you, to show it on a diagram. But this one you have to visualize it, right? There's a sheet of metal, right? They're gonna form the container. But they're gonna cut out the corners, right? And this is 16 by 13. So this is 16 meters by 13 meters. I'm gonna draw it over here first. I'm gonna show what happens afterwards. So like you start out with that, right? And what happens is that you take out the corners. You cut out the corner, you cut out x by x here, so it's gone, you know, all of this gone. Cut out that x by x and cut out this x by x as well. And cut out x by x here, so cutting out squares, right? And cut out x by x. All of these corners gone, you know. So this gone, that I'm marking out in red. You cut it out. You cut out those, right? You cut out those, and this is x by x. X by x, x by x, x by x, x by x. Alright. So when you cut out that now, you know, what you're gonna have left? What are you gonna have left? You're gonna have the net of the container to make it. So you're gonna have something looking like this left. You're gonna have something looking like this. You're gonna have something looking like this left. Like so. It's a square in the corner there, so you come down here, so you go back, so come down, so you have this piece up here, come down, go across, come down, go back in like that, and come down and go across. Something like that, right? Not so perfect, but you know, hope you get the picture. So you cut out the corners. So these gone, them corners is a cut out. Them corners is a cut out and gone. So that is what you have left after you cut them out, right? So what are the dimensions on this now? So since remember over here so was 16, you cut off x off x and x off x. So what you have left right here so now is 16 minus x. You know? Yeah, man, I remember these questions. Up here so is also 16 minus x. And on this side now, it was not x, 2x, right? Not x, it's 2x, you cut off x and x, yeah. 2x, you cut off 2x, and cut off 2x. Now, by this side, I also cut off 2x. It was 13 originally, now. So now this is what I have left is x 13 minus 2x, right? You know, I have 13 minus 2x, right? Just 13 minus 2x. And this is 13 minus 2x as well, right? 13 minus 2x. All right, that's what you have left after you cut out where you're cutting out. So must be sure. It's 2 marks for it, you know, but you have to understand it. I was explaining it. It's easy enough. Say 2 marks. But you have to understand what is happening. And then what happened now is that these edges or these little pieces gets folded up. They get folded up, right? So when you fold them up, you see if I can sketch the resulting container now. When you fold them up. When you fold them up, right, the container becomes a cuboid shape, you know, cuboid shape. So it becomes a cuboid shape container, like something looking like this. Let me see if we can draw it now. So we can draw that now. It's gonna look like. It's gonna look like this. Something like that. Cuboid shape. Come across the front. You fold it up. And then you have the back piece there, so you come across that. That's what you're gonna look, you know. And you have the bottom piece here and there. And come across there, and something like that. When you fold up the sides. So what happened now is that this right here so is 16 minus 2x. And here so is 13 minus 2x. But then the height of the thing is x. Height of it is x, you know. Remember, you know, this is a piece here, so now when you fold it up, it is x. We must write it so it was x, you know, and x, right? So you close it up now, the height of the thing becomes x and the top O. And then the volume now is just the product of these things. Give it the volume. That is it. So I just draw the diagram to show you what is happening. You could have figured it out. So show that the volume is this. So the volume becomes this times x. I can put x times these two. So let's take it away there. So x times 13 minus 2x times 16 minus 2x. And that's what I'm multiplying now. And what we're done is supposed to get this. All right, let's open, let's see. Equals x into, we're going to multiply these two first. What is 13 minus 16? Let's see. 13, not minus, 13 times 16. Let's see. 208. All right, start already. So 208 in the answer here. So 208, beautiful. So this time, this is 208. 208. And then the middle term is the far product and the near product, right? So the far product is going to be 26x. And the near product is going to be 2 times 16 is 32. 32. So 26 and 32, that is 58. So I'm gonna get 58x in the middle term. 58x. 58x in the middle plus 58x. And then you're gonna have this times this one will be a positive 4x squared plus 4x squared. And then just multiply each of these with the x now, and let's look at the answer. Same thing, yes. X times the 4x squared is 4x cubed root to 4. 4x cubed. Then x times this 58x is 58x squared. 58x squared. And then x times the 208 is 208x, which is what they told us to show. Just like that. Beautiful. Quite easily brushed aside. Soft with a capital T. Yes, it must feel nice when you solve questions, right? All right, that was a nice one. Yeah, remember it from back in the days. Yep. So I must have plenty maths. Sometimes you just remember stuff. All right. This one says no. Using the method of second derivative, determine the height that will maximize the volume. All right, so we're going to have to differentiate. So I'm going to copy over this formula for the volume. I'm going to differentiate it. Right? It's a cubic, you know, so you're going to have a maximum and a minimum. I want the maximum. I have to decide which one is the maximum with second derivative. Okay, let's paste it over here. So differentiate it. I'm get the stationary values first. When we max and when we min. They want us to find the max. They're interested in the max. Alright, so this is our volume. Normally, I want to differentiate it to find the stationary. It's not a plus and there's a minus. A mistake. The middle term is a minus. The middle term is a minus, minus, not a plus. Actually, a minus right here. Minus. Don't give it away, Mr. Shaw. Don't give it away. Minus right there. All right, I differentiate it now. So dv by dx stationary. It becomes 12x squared. 2 times 56 is what? 116. 116. Because 2 times 50 is 100 and 2 times 8 is 60. 116x plus 208. 208. This is equal to 0 at the stationary points. We need them. Observe that. Find the x value at stationary point, and then d2 by dx2 to find the nature. Which one is maximum? Which one is minimum? Right? So let's find the values of x first. Alright, so we're solving this right just now. So we can divide 2 by 12. See that can divide by 12. 116 divided by 12. Nope. So we cancel it down. Cancel it down. Can divide by 2 or 4. This can divide, yeah, this can divide by 4. 116 divided by 4. Alright, can divide 2 by 4. So divide this by 4, we're going to get 3x squared. Divide this by 4, we're going to get 29x plus divide this by 4. This much we get. It's going to be about 52. 208 divided by 4. Yeah, 52 equals 0. Alright, and I'm going to factorize this now. Let's factorize our physical quadratic formula. That's a prime factor. Let's try. Factorize it. Let's see. Equals 0. So it's 3x and x are the only factors of 3x squared. 3x and x. One factors of 52 now, where the sum of the far product and the near product is 29. 52 divided by 52. Virgin by factors 4. Let's try 4 and 13. 4 and 13. So 13 and 4. That's 12 and 13. That's 12. 12 and 13. I know it's 29. That's the number. Yeah, we're thinking on the 4. Let's try 8 and something. Let's try 8. I'm just searching, guys. I'm searching. 4 and 13. Seeing it yet. I'm seeing it. 26. We want the sum. 26. Yeah, 26 and 2. Wow. 26 and 2. Yeah, because it's a 6. And mama. 6 and 2. No, only we can't factorize. Man, we can't factorize. We can't, brother. I'm gonna go the long route. Let's try the long route. 3 times 52. Let's try that route. 3. Usually these questions can factorize now. 3 times 52 is 156. 156. So factor of 156 that add to 29. Factor of 156 that add to 29. Factor of 156 that add to 29. Try them. 3. Searching for it. 4 times 39. 3, 12 times 13. Can I put make a mistake somewhere. Let's see if I make a mistake somewhere. Let's see if I made a mistake somewhere, guys. Let's see. 6. Let me pause the video and work it out. Let me pause and work it out. Pause and work it out. Hold on. Let me pause. Let's work it out. So that is going. I don't know why it's a quadratic formula. You know. I fail to believe I need to use a quadratic. All right. Can't factorize. So let's have use the quadratic formula. I could compute the square now, but let's use the quadratic formula. So the x is gonna be big question, man. Usually I don't allow you to use the factorizer stuff like this. X is gonna be minus b becomes 29 plus or minus the square root of b squared, which is a negative 29 squared, same as 29 squared, minus 4 times the a, which is 3, times the c, which is 52, all over 2 times a, which is 3. That's what we have to work out. All right, so let me see now. It becomes 29 plus or minus what comes under here. Let's see. 29 squared. Working it out on my calculator. My hand minus 4 times 3 is 12 times 52. 217 under here. That's the perfect square. Divided by 6. So you're gonna get one value with the plus and one value with the minus. Let's write the decimals. X equals. Let's write the decimals. So it's gonna become 29 plus square root of 217, and then you divide that by 6236. So you're gonna get 7.29, or x equals 1 with the minus, which is 29 minus the square root of 217. Throw that out, and then divide that by 6. Divide that by 6. It's gonna be 2.38. 2.3. I don't like these answers, but that's what we get. 9 marks. Then now we have to do the second derivative to see which one of them give us the maximum, right? So we're going to do the second derivative on this. So we're going to do d2v by dx squared. Zoom it up and make it smaller. Right. Zoom it up and make it smaller. Write what it is first. Differentiate that, we're going to get 24x minus 116. That's what we're going to get. I want to see which one of them positive and which one negative, right? Question says use second derivative to determine the height h that maximizes the volume. So I want to know which one of these makes it maximum, right? So test them, the smaller not test them. The smaller not test them. Alright, so at x equals 7.29, x equals 7.29, d2v by dx squared becomes 24 times 7.29 minus 116. What is that? That positive or negative? One that is negative is going to give us the maximum. All right. So let's see what is report. So that's 24 times 7.29 minus 116. That come out positive. This is greater than 0. This one giving us the main, so not this one. There's the other one, which is x equals 2.38. d2v by dx squared becomes 24 times 2.38 minus 116, which is less than 0. And therefore, this is the one that gives us a maximum. So the answer is x equals 2.38. That's what the asks us final. Which one will maximize it? Right? Determine the height x that will maximize the volume. So this is the answer right here. That's the answer. That value of x will maximize. And then say determine now the maximum volume of container. So to do that, plug this now back into the volume formula right up here. Plug it in there. That will give us a maximum volume. Then we copy it on again. Copy. Place it down here. Just one mark for that. So that is V. So V max will be 4 times 2.38 cubed minus 58 times 2.38 squared plus 208 times 208 92.38. Work that out, the maximum volume. We're in meters, right? We're working in meters. Yes, meters. You have to write meters cube and the answer down here because it's a volume. Meters cube. Cubic meters. You can write this out quick. So it's 4 times 2.38 cube raised to the power 3 minus 58 times 2.38 squared plus 208 2.8 208 times 2.38 equals, so within 220.4. I'm giving to one decimal place. All right. Well, if I made a mistake with the numbers, then it just mistakes with the number. The process, I'm certain of the process, the procedure is correct. Certain of the procedure that I use is correct. I made a mistake with the number, the value. I don't like this kind of decimal answer. That might just be the correct answer. All right. So we've done it 5 questions. You know, the last question. So I don't see which question I say hard yet. All right. Don't see it yet. Yeah, the question are kind of unreasonable because they put the H and the R on it. I don't like the fact that they put the H and the R. as dimensions, as fixed dimensions when they were actually varying. Shouldn't call it R. They should just write they should put the 16 and the 8. Right? Shouldn't call them R and H. That alone might throw off. But anyway, now you know. Let's look at this question now. Number 6. All right, that's what this is now. I'm going to pause it there. What is this? All right, so we're at number 6 now, Jordan. Number 6. It says calculate the volume of a solid generated by revolving the region bounded by the line y equals 3x minus 6. That's this line. And the parabola y equals x squared plus 3x minus 2. That's this curve right here. In the interval -2 to 1. This means the interval between not -2, 0 and 1. That's what it means, right? This means between 0 and 1. About the x-axis, there's volume. Remember, volume about the x-axis is pi times the integral of y squared dx. So this is like a compound region that they want us to do. They're not intersecting, right? So which one gonna give us the larger volume? So the line is basically 0 to 1. So we're gonna be revolving this region around the x-axis under the line, right? This area, all of that is gonna be revolving around the x-axis. All right. So when you revolve around the x-axis, it's gonna basically come out with a solid looking something like that. All of this. It's gonna be circular, like so. And this end also is gonna be circular, right? Like a frustum, like so, right? And then now we'll do the red one. If we do red for what the curve is gonna give us, right? So the curve, this is a curve right here, remember? So the curve now between 0 and 1. This is around 1 is right here. So the curve now is gonna be this area. It's gonna be revolving as well around the x-axis. So it's gonna trace out. So almost looking like a cone inside here. So revolve it. Almost looking like a cone, right? So basically it's gonna be the area, the volume generated by the under the line minus the volume generated by the curve. Simple as that. So the volume generated by the line minus the volume generated by the curve. So like you do the curve, the line is gonna give you a larger area than what the curve is gonna give you. So you have to subtract to get the difference, right? Because yeah, it's like the curve is gonna, you want to reach them between them. So if you want to reach them between them, so it's almost like you want this region. Let me do it another way. Like you want the region form out here by this. If you include curve, so like you want the region form out by this thing, right? Right? So it's like when you form it out, the space is gonna be left. It's something like so. Something like so. Something like that, right? Something like that. It's gonna form out, but it's gonna be circular. Anyway, no matter. The volume generated by the line minus the volume generated by the curve. All right, so the line equation is this, and the curve equation is this. Wow, we have to square this, you know, guys. We have to square that. Remember, volume is integral of y squared dx. There's so much space to give for this one. Oh, they give 2 pages, because I know there's a lot of work. All right, ready. So the line gonna give us a bigger volume than the curve. So all right, let's do the line. So line. Let's do them separately. Line. Then do them separately and subtract them, you know. Or we can set them up and make them into one. one volume of revolution. But the line, which is y equals 3x minus 6, can square it from now and see what it will be. Y squared, if we square this, we're gonna need a square. We're just basically working it down. Y squared is we're gonna square this. So we're gonna get the first term squared is 9x squared. Then twice the product of the 2. Multiply this and this, you get negative 18x times 2. 18 times 2 is what? 30. 2 times 6 is 18. 18 times 2 are 36. 36x. Second term squared is 36. All right. 18 times 2, 39, 2, 9, 2, 8, 36. That's it. 36, and then this squared again, we're gonna get plus 36. The squared, right? So we're gonna be integrating this between 0 and 1, right? And then for the curve, work for the curve is more now, right? So the curve is y equals x squared plus 3x minus 2. I'm going to have to square this 2 now, so I'm going to set this up. I'm going to have to square this one, right? I'm going to zoom it up and set it up. So what the square is going to be. I'm going to have to integrate this square. That's basically doing the groundwork. I'm going to have to square this. Let's set it up. Let's work it out step by step. So with the y squared, it's going to be x squared right below. We'll square this to get the volume. It's going to be x squared plus 3x minus 2 times x squared plus 3x minus 2. All right, I'll make sure that is the right equation. Plus 3x minus 2. We're going to expand this out into separate terms. So y squared is going to be this times this first is x to the 4th power. And this times this is 3x cubed. And this times the 2 is minus 2x squared. We're going to multiply with the 3x now. So 3x times this is 3x cubed. Put it under here, so 3x cubed. This is supposed to be a cube, you know. Cube. 3x cubed. Right, okay. All right. So this time it's already get 3x cubed. So when I do this time this, I get 9x squared. So we get plus 9x squared. So this times this, I'll get minus 6x. Minus 6x. I'm going to multiply with the 2 now. So we're going to get 2 times this and get minus 2x squared. Minus 2x squared. Putting like terms on each other. Minus 2 times this is minus 6x. Again, minus 6x. And minus 2 times minus 2 is positive 4. With a plus 4 out here. So the y squared on this is going to be, this is the only 4 to the 4, x to the 4th power. And the cube terms is 6, so that's plus 6x cubed. And then the squared term is 9 minus 4. 9 minus 4 is 5, so we're going to get 5x squared. And then the x term is negative 12x minus 12x. I'll add the 4. All right. We're integrating between 0, but this is a curve. All right, so we're gonna do the line minus the curve. So we can do this equation minus this equation now. All right, we're just making the groundwork. So we can do line minus curve. Get what that expression would be. All right, that's the integrating between the same two limits. The line minus curve, right? Line giving a bigger area. All right, so we're gonna get minus x to the 4th. In terms of the square, this is this minus that. In terms of the square, what it says 4x squared. Let me write it. So we're gonna get 4x squared 4x squared. So this and this did already. In the x now, minus 3x minus give it a plus. So I get negative 36 plus 12, negative 24. So I get minus 24 x. Then a constant now is 36 minus 4. That's 32. So that's underline over here already. So let's have these two now subtracting them, subtracting them. So you're gonna minus the x to the 4th power and also minus 6x cubed. I'm gonna have to integrate this now to get the volume between 0 and 1. So we'll set the groundwork over here already now. So the volume, I write this formula in for volume, and it's between 0 and 1. But it's a curve, the volume generated by the line minus the volume generated by the curve. We'll subtract them already between 0 and 1. So the volume required becomes equal to the integral. No, don't forget the pi. Don't forget the pi. Pi times the integral between 0 and 1. The difference of the two squared values, which is this. Alright, so we can just copy that over and put it. Okay, and put it up here. So we're integrating. Alright. With respect to x, I'm gonna put in the dx. It's gonna become very easy because only the one is gonna give you a value. So we'll set the groundwork over here now. So the background work over there, and we're ready to integrate. So now says the line equation minus the curve equation after you square them. So I'll square them first. Alright. This is an easier way to do it, I think. You just separate out the work like that. So I just need to work this out now. Good. It's ready. So this becomes equal to pi into integrate this to get 4x cubed over 3. Integrate this. Add 1 to the power, get 2 over 2. So I get 12x squared. I get minus 12x squared. It's going to give me 32x. This is now going to add 1 to the power and divide by the new power. I get minus x to the 5th power over 5. And for this one, I'm going to add 1 to the power, get x to the 4th. So I get minus 6x to the 4th power over 4. I integrate in between 1 and 0. But the 0 going to give you a 0 everywhere. All of these values out here are going to give you a 0. So you know that the 0 will not matter. And then this is 1 you're plugging in. So all these values equal, easy to work out because it's 1. So pi into the 1 is going to become 4, 3. It's going to become negative 12. It's going to become plus 32. It's going to become 1/5 minus 1/5. It's going to become minus 6 over 4 or minus 3 over 2. You can put minus 6 over 4. That's what the 1 gives us. Subtract the 0 is going to give you 0. Let's show it. Let's see to work this out now with my calculator and put it in terms of pi. Let me bring up the calculator. Let's do it on the screen. So it turns out to be a nice, easy question. Once you square up your values, are good. So it's 4 over 3. And then subtract 12. And then add 32. And then subtract 1 over 5. Then subtract 6 over 4. 6 over 4. 6 over 4. And get down to 19.13 repeated. That's what that is. It is 287 over 15. So that works. So and you put the pi. 287 over 15 pi units cubed. That's it. Some long work to do, but the easy work, right? Not difficult. All right, so the area generated by the line, the region minus the area generated, the volume generated by the line minus the volume generated by the curve. That gives us that answer. 7 marks for that work. That's an easy. 6A done. 6B, which is this. So I see the cos graph and the sine graph. It says diagram below shows curve y equals cos x and y equals sin x. Okay. So determine the area bounded by the curves between pi by 4 and 3 pi by 2. Wow. Area bounded by the curve between pi by 4. No, pi by 4. This is pi by 2. No. So pi by 4 is this line. And 3 pi by 2 is this line. So we want the region bounded by the two curves in that interval. So the region in between the curve I want, you know. It's kind of mad. Can't integrate it just directly and subtract them, you know, because you're gonna have some negative errors in here happening. So the best way to approach this is to sort of break it down. Identify the region that you want and break it down into parts, into pieces. All right, so let me identify the region that we want between the curves. So the region between the curves in that interval, let me shade it out, is inside here. Inside here is between the curves. But that is just, so far is just up to there. Eh? And you also, because you have another piece out here, so you also want a region between the curves here so as well. That's this region right here. So. All right, so we want to here that I've shaded in blue. We're gonna get that now. All right, if I break it down. Break it down. All right. All right, we're gonna approach it now. We're gonna approach it. All right. Show you we're gonna approach it. There are multiple ways to do it, you know. We have to be careful. All right, let me show you something now. Mark the same way. You see this area up here, so let's call it area 1. It's the same area down below the x-axis here, so. So if I find that area 1 up here, so multiply by 2. That will cover the area in between the curves in here, so. All right. So 2 times area 1. 2 times area 1. So find area 1 and multiply by 2. That govern for inside here, so in between the curves there. So this section now to get now. I don't want to work over the negative part, you know, because the negative part can mess you up, because when you integrate in the negative part of the curve, it comes out negative. Sometimes it messes you up, right? What we have to realize though is that the area right here, so the same area between up here, so same area, you know. Yep, the same area. So instead of finding this area down here, so you can literally just find this one right here, marked in a different color. The area in between the curves right here, so the same area right here, so you know, same area. And so I'm gonna call this area 2. Area 2. Right, this area right here, so area 2. So basically then, based on this, I need 2 times area 1 plus area 2. Because area 2 is the same area down here. So that will give me the area that I want. Area between the two curves. The question is, how do I find area 1? I'm talking about in here, so you know, up here, so this half of it. Alright? I need to get area 1 out of that half. So I'm going to find the area under the sine graph. That's the sine graph here. And then subtract the area under the cos graph, which I'm going to mark in green, between 0 and pi by 2. That will give me area 1. So the area under the sine graph minus the area under the cos graph. And the area of the cos graph go from here to here. This is pi by 2, and this is 0. All right. So it's actually from pi by 4 now. Yeah, right. It says pi by 4. Yeah, that's what they did say. Right. It says pi by 4. Right here is pi by 4. I just figuring it out first before we do it, right? Good. So all right. So to get area 1 up here, so which I'm going to multiply by 2 to get the other part down here, to cover the area inside here, to cover the area in between this section. Then I'm going to add this area to cover for this area, to account for that area. All right, that's what I'm going to do. So how do I get area 1? It is the area under the sine graph. Sine graph is the top one right now, right? The unbroken one. Here on the sine graph between pi by 2 and pi, right? It says pi now. Right here, so it's pi. Minus the area under the cos graph, the green section, the area under the cos graph between pi by 4 and pi by 2. Write it out from now. All right, so I'm write it out from now. What to mean? So much space to give us for this. 2 page again. Wow. 2 page. Also, these are the questions the people them say problems. All right. All right. I'm gonna leave all them sketch on the graph on the question, on the graph, because remember the paper going in with the solution, right? So I'm gonna say the area required is equal to 2 times area 1. And this I'm talking about this area. Plus area 2. Plus area 2. This is area 2 that I have up here. Because I'm using this to calculate this area, because it is the same area, same shape. Just set it upside down. So what is area 1? Let's figure it out step by step. So I'm doing 2 times. Can we correct them all separately and then drop them in this time. So let's work out area 1 now. So this is what I want. I'm gonna work out area 1 and area 2 separately. All right, so I already know. Work them out separately. So area 1, when I multiply by 2 after I get it, area 1 becomes equal to the area under the sine graph. So the integral of the sine x graph with respect to x between pi by 4 and pi. Between pi by 4 and pi. Then we have to go subtract the area, the green area there, so now. The green area. I have to take that area out. We'll subtract the area under the cos graph. That is between pi by 4 and pi by 2. Right? The green area is between pi by 4 and pi by 2 under the cos graph. The broken line is the cos graph. That's going to give me area 1. Let's work it out right now. Right? Over that space. But that is what will give us that area. Remember, make it smaller. So we can lower this one at them here. All right, let's work out this one. So this is gonna be that area 1 is gonna be integral of sine is minus cos. I'm gonna differentiate cos to get minus sine. So I get minus cos x between pi by 4 and pi minus integral of cos is sine, because differentiate sine you get cos. You're gonna get sine x between pi by 2 and pi by 4. That's what we're working out. All right, let me copy this over the next page. Continue. Let's copy this over the next page. Copy. Working out area 1, I'm multiply area 1 by 2. So let's work this by itself right here. All right, let's zoom and work it. All right, so area 1, which we're gonna need 2 of them, is I'm gonna plug the pi in this. So we're gonna get in the bracket minus cos of pi, and then minus a negative cos of pi by 4. All right, so it's minus cos of pi minus a negative cos of pi by 4. That's what we get in this bracket. Minus, and do the sign one now. Becomes sine of pi by 2. It's supposed to be pi by 4, you know. Let's go back at it. It's from pi by 4 to pi by 2. Pi by 4 to pi by 2. Yeah. Pi by 4. It's supposed to be pi by 4 only. So this is pi by 4. Alright. So sine pi by 2 minus sine of pi by 4. And these are some easy values. You don't need a calculator. So the area equal. The cos of pi is negative 1, you know. This is negative 1. So it becomes a minus negative 1 becomes a 1. Bang. Because this is negative 1. Cos of pi is negative 1. When you know these things, the mathematics is just easier. Cos of 0 is 1 and cos of pi is negative 1. Right? So this my negative 1. So this minus x becomes a 1. That becomes a 1. All right, step by step, I'm taking my time. I'm going to minus this now. That's that minus. I'm going to have a negative cos of pi by 4. So this minus is going to make this a plus. And the cos of pi by 4 is root 2 over 2. That's in the first bracket. Minus the second bracket, you know, the sine of pi by 4 is 1. Minus sine of pi by 4 is root 2 over 2 again. So this really works out too. This must be some used. All right, doing well so far. So let's consolidate this for area 1 then. Let's put it right here. So it's 1 minus 1. So the 1 gone. Then you have root 2 over 2 minus a negative root 2 over 2. So you get 2 root 2 over 2. So that works out to root 2, you know. Because it becomes this plus this. So just get root 2. Imagine that. So area 1 is just root 2. I only need 2 of it. I need 2 other area. The top part and the bottom part. Right? Let's work out area 1 now. Which is the area under the cos graph between 0 and pi by 4 minus the area under the sine graph between 0 and same pi by 4. Right? That's area 2. Let's work it out now. So area 2 is the integral between 0 and pi by 4. Which graph that up? The cos graph, right? Of cos x dx minus same region, same interval, 0 to pi by 4 of the sine x graph dx. Because these are the same limits, we can literally just consolidate and write area 2 equals the integral between 0 and pi by 2 of cos x minus sine x dx. Because they have the same limit. So that's what we'll do. Pi by 4, right? Pi by 2 is supposed to be pi by 4. Don't give it away. Pi by 4. So area 2 is gonna be integral of cos is sine, because we differentiate sine, I get cos. So you're gonna get sine x. But the integral of minus sine is cos. Okay, when differentiate cos, you get minus sine. So it's gonna become a positive sine cos x between pi by 4 and 0. Don't assume that 0 gives you 0, but the cos of 0 is 1. So ready now, plugging in the values now. Wow, on the space. I'll make some of this smaller. Some of this smaller on this page. Just make it smaller. As you know, nobody reading the digital can always zoom up, you know. That's why we can always make it smaller and this. We can zoom up. Alright. So ready now. Plugging in the pi by 2, pi by 4. So we're gonna get the area 2 equal sine of pi by 4 plus cos of pi by 4, which is the same, minus, plug in the 0 now, sine of 0 plus cos of 0. So area 2 equal, notice a pi by 2 and pi by 2. No, even pi by 2, root 2 over 2. Root 2 over 2 plus root 2 over 2. Let's write it out. Minus sine of 0 is 0 plus the cos of 0 is 1. What is work out to? Let's put it right here. Now this is root 2 over 2 plus root 2 over 2. So it becomes just root 2. So this is just root 2. This is just root 2. And this is minus this 1. So it becomes root 2 minus 1. That is area 2, you know. So the area required, remember. Area required. That's a nice question. I like it. Remember, is 2 times area 1 plus area 2. So it becomes area 1 was what again? Area 1 was root 2. So it becomes 2 root 2 plus, and area 2 is root 2 minus 1 plus root 2 minus 1. Zoom up. All right, it's here. So the final answer is 3 root 2. 3 root 2 minus 1. I have to say units squared. I like this question. I like it a lot. This was a nice question. Love it. I like it. Yep. All right. Wonderful. That's a good question. This question will test your test you in an exam and separate men from boys. You know, because you really have to just sometimes drill down and look at it carefully. All right, so I hope I explained it good. Next question. Finishing now, we're in the last part. See, end of test. So basically finishing these two quick section left. All right, it says on the surface of the moon, acceleration due to gravity is this. What is this about? A rocket is launched away from the moon, so the gravity is going to act on it, right? With an initial height of 1,200 meters. So the rocket has an initial height, so it's like it's 1,200 meters off the ground, and an initial velocity of 30 meters per second. So when it is launched, it has a velocity of 30, but this acceleration is acting on it, right? Wow. There's an initial height of 1,200. All right. And the acceleration is -1. So, all right. So I didn't know that motion and straight line reach and pure mass now, you know. But it's like a motion and straight line thing, but then it is on the advanced syllabus. So advanced is a prerequisite for pure mass. So maybe that is what is happening. Right? They want us to determine the velocity and the height of the rocket 5 seconds after launch. So what they gave us here was the A, the acceleration. A. So I'm going to go back to the equations of motion. So the acceleration is the rate of change of velocity with respect to time. And they tell us it is -1.625. -1.625, 1.625. So then to get the velocity, we have to separate the variables, multiply the dt over here, and so much. So we're really working on this part, we're working inside here. All right, so we're going to get that the velocity equal -1.625 dt. Sorry, not the velocity, dv equals that. And then you integrate both sides. Integrate both sides and put it in purple. Integrate this side and integrate this side to get that equation. Because there are no limits, you're going to get a constant of integration. And that's why they tell you this. Initial height, that means when t equals 0, you know. Initial velocity is when t equals 0. All right, so when you integrate the v, integrate dv, you're gonna get just v, right? Equals, because like integrating 1 with respect to p. Integrate this again, there's multiply by the t, you're gonna get -1.625 t plus a constant. Let's call it u or v. Let's call it vi, the initial velocity. Let's call it the initial velocity. And what they tell us that basically when t equals 0, that the velocity is equal to 30, which means that this is 30 and this is 0. So the initial velocity is 30, right? So the initial velocity is 30. That is the constant. So the velocity formula is negative 1.625 t plus 30. What they want the velocity after 5 seconds. So we can write that out from now. So when t equals 5, the velocity becomes negative 1.625 times the time of 5 plus 30. And this will give us the velocity when t equals 5. That velocity you can work out here. Let's use my calculator that I have. So I'm doing 30 minus, that's going to be 30 minus the product of these two. 30 minus 5 times 1.625 equals, I'm getting 20.25 meters per second. That's the velocity. So this is an answer. This is an answer. That's an answer for the velocity equals 5. Then now we want to get the height, which is really the displacement. Right? 5 seconds after launch. So we're gonna come back now, take this velocity formula, and know that velocity is ds. In this case, the s is h, right? dh by dt. The displacement, right, is equal to the negative 1.625 t plus 30 plus 30 plus 30. So this now we have to separate the variables again. Put that over here. We can simply say that the height becomes the integral of negative 1.625 t plus 30 with respect to time. What space we have there? Hold up. Space down. We have the height of one answer already. Then now we're going to integrate this and put in a constant again. So h equals, integrate that, add one to the power and divide by a new power again. Negative 1.625 t squared over 2 plus 30 t, we integrate this, plus the initial height, let's call it h over the initial height. And so when t equals 0, this is up here. When t equals 0, the initial height was what? Does it? Initial height was 1200 meters, right? Initial height was 1200. And therefore the HO, because you put 0 here, 0 here, and 1200 over here, we're gonna get that this HO is 1200. It's 1200. Alright, so the formula for the height becomes negative 1.625 t squared over 2 plus 30 t plus 1200. And they plug in what that meant t equals 5. When t equals 5, that height becomes negative 1.625 times 5 squared over 2 plus 30 times 5 plus 1200. And that's what you're working out. See, we can shift this up a little bit. Right here. You can see that's right answer down here. So h equals, let's write it down here. So Write this out and write it under there. All right, let's work it out. But this is negative. So I'm going to do the 1200 first. I'm now going to add that 150. 30 times 5. And then I'm going to subtract. Let's start this minus. I'm going to subtract this calculation, which is subtract 1.625 times 25. 5 squares 25 times 25 by the same time by 2. Right, equals. So I'm getting 1329.7 meters. That's my other answer right here. This is my answer. So make this a little bit smaller. This one a little smaller. Right. So this becomes the answer for the second for the height. Just have to calculate the velocity and the height here. Velocity and height. The rocket. That's that. Nice question. Nice question. Then we come to this final one over here. Finish off this paper. It's 2023 paper. Nice and easy. So this is something like this to integrate. You have to use substitution. The substitution is going to be on this. You're going to write it like this. It's going to become equal to the integral of cos 2x all cubed and the sine 2x dx. And the substitution is u equal expression in there. Why? When we differentiate the expression in here, it basically appears out here. The differential of cos is minus sine. So substitution to use is u equals cos x expression within. All right, let's go for it now. Let's call this integral I. Let's just call it I for integral, so we can reference it. So initially, you're gonna make the substitution u equals, and since you're not going to tell you, you have to know so you have to make a substitution. U equals cos 2x. So du, differentiate this side, get du, differentiate cos, get minus sine. You also have to differentiate the 2x and multiply. So you're gonna get minus 2 sine 2x minus 2 sine 2x dx. So the du that was the dx that would have been under here, basically put it out there. So why did I do that? Because I'm trying to generate an expression on this side inside here, so we can replace it with a du. All right, so it means I'm going to adjust this. Let me shift this over some. Show the adjustment. So that's what we have so far, right? We can make the substitution, but we need to make some adjustments. Look at the adjustments now. I need to get this over there. Close enough. What is missing is that negative 2. What I'm going to do, I'm going to put the negative 2. I'm going to cancel with the negative half outside. So the integral, let's put it down here, is going to become negative half. I'm putting a negative half. Times the integral of cos 2x cubed. Why did I put the negative half? Because I'm going to multiply and put the negative 2 in front of this. So I'm going to get minus 2 sine 2x dx. So it now means that I have this out here. Right? All of this comes du. So now I can apply my substitution. This is integration using a substitution method. So this inside here is my u. So you see this balance out, but that minus 2, you know. Balance out each other, right? Balance out each other. If I put them in ready, and put them in ready. Those who maybe will see the paper 1D. I just see the working out. It's in red. Change it to red. Change this -2 to red as well. So that is the adjustment that was made. That's it. The balance of each other as I'm trying to generate this. So now I'm generate this under here. So now I'm ready to do my substitution. So the integral becomes -1/2 integral. Now the cos x, cos 2x is u. So it becomes u cubed. And this whole thing is now du. Du, so it is equal to du. That's the substitution. So it comes on to an easy little integral to do. So I equals -1/2. You're gonna add 1 to the power, you get u to the 4th power, divided by the new power of 4. Don't forget to put your c plus c. Okay. And that's it. You can just continue down here. So continue. It's just a matter now of substituting this now back for the u inside here. Sorry, no. So all right, the final answer here, we're gonna get the integral is, this and this give me 1/8. So I'm gonna get the minus 1/8, and then this becomes cos to the 4th power, cos to the 4th power of 2x, cos to the 4th power of 2x plus c. That's what it becomes. That's my answer. And that is that. All right, I don't even know how long it took, break and slow down, and yeah, but that is it. I think this was a nice paper. Nice paper. Nice paper. Yeah, model 2, there are a couple nice questions in it. Really. No, trying to follow this line. There are a couple nice questions in it for real. I'll put this in a box. The substitution that we made. All right, then take this off. That's my answer. Make by the substitution for the u. U to the 4th power becomes cos to the 4th power. No, see, I make a mistake. It's 2x enough. Wow. This is 2x, not x. 2x, don't give it away, Mr. Shaw. 2x. Sure, we differentiate with the 2x, we did differentiate, yes. So the 2x there, the 2. Anyway, that's it. Yep, that's it. All right, I'm gonna end it now, and then I'll send the video to Jordan. Keep it for future uses. For those who end up watching this video online, I teach Parametric and add math and C-set maths. My number is 876-881-5600 in Jamaica. You can send me a WhatsApp there as well. All right, don't need no email. You don't need to work with email anymore. So, yeah, that is it. I am sure. Okay. All right. So if I reach out for me, reach out for me for classes. All right. Join the program. All right. I'm gonna end it now.